All right. Well, welcome everyone. This is the IUU fishing panel. Before I introduce the panel members, I want to welcome the virtual participants from this year's BlueTech Week. And this again is the illegal, unregulated, and unreported fishing combating panel. My name is Allison Caputo, and I am the Chief of Planning at the Customs and Border Protection Office of Intelligence in San Antonio, Texas. We monitor the southwest border and its approaches to include littoral areas off of Texas and California, and we guard against transnational criminal organizations. Prior to this, I was off Alaska, and I was the chief of enforcement there, combating IUUF in the North Pacific and along the Russia-US EEZ boundary. Previous to that, I was the chief of fisheries enforcement at Coast Guard headquarters, where we implemented the Port State Measures Agreement, and we implemented port sanctions against Mexico for their illegal fishing fleet that was occurring along the Mexico and Texas border. I've been assigned to 5 different cutters. I've been conducting IUUF operations as far north as the Arctic, as far south as the South Pacific, as all the way over to China, and then off the coast of New England. I've been to a lot of different enforcement operations and a lot of different enforcement meetings around the world. And in my experience, there's kind of 3 big problems that we face today. The first one is basically illegal transshipment at sea, where 2 vessels meet up with one another and they transfer cargo, and it's very difficult to understand where the fish came from or how it's labeled. The second issue, that is the biggest one, is dark targets. This is mostly how we describe them, but basically it's a fishing vessel that goes out, and most fishing vessels today use all kinds of electronics. They use radars, they use phones, they use vessel monitoring systems. And what they'll do is they'll turn all that off so that they can go fish illegally in a space. And the last biggest problem that we have in IUUF is typically transnational criminal organizations that will fund these fleets or subsidize them. They will use forced labor, and they'll use a lot of sort of nefarious practices to transport and trade in illegal products. So those are, in my perspective, are what are some of the biggest problems that we face today. I'm really looking forward to hearing from our panel and how technology and autonomous vehicles can maybe help improve combating IUUF. First, we'd like to start with Mark Gundersen from Marine Advanced Robotics and Chase Pietenpol from Overwatch Aero. Mark and Chase, go ahead.
Great, thank you very much, Captain Caputo. Chase and I will be presenting on a project, a demonstration we actually did last month. This one is specifically about combating IUU fishing. And we did this in the Dana Point State Marine Conservation Area using the WAM-V USV and the UAS system you see here that Overwatch Aero has. Next slide, please. So just to kind of talk a little bit about the scale of the IUU problem. As many of you know, this is a massive problem. We're talking of economic losses in the billions of dollars. And this is in some areas where, some island nations that depend heavily on fishing for both revenue and for subsistence. And we're also looking at a problem that, has kind of these big ramifications going forward when you start talking about the environmental loss, right? So this is something we really want to focus on coming up with solutions, technology solutions to combat this problem. Next slide, please. Chase, are you there?
Can you hear me? As Mark said, it's a large economic problem, but it's also a huge problem when it comes to a geographic. As we've heard this morning, it is breadth and scale from the Arctic to the Antarctic, from littoral waters to deep blue open ocean waters as well. And so we think that in order to combat this problem, long endurance autonomous systems are going to be critical for future enforcement efforts, both from a tactical level, meaning informing law enforcement officials and possible interdiction teams with the best real-time information possible, but also on the back end, supporting court convictions and legal proceedings on the back end. And both Mark and I believe fully that long endurance autonomous systems, particularly multi-domain systems, meaning air, surface, and subsurface systems, as well as multimodal systems, video, thermal collections, acoustics, signals collections, will support these efforts at a fraction of the cost as well as in a very safe manner. Next slide, please. So, as Mark mentioned, we provided a demonstration in the Dana Point area last week, and this is a very condensed highlights video of what we were able to accomplish. So in this case, both the WAM-V and the airplane are long endurance and were launched from shore. The system is capable of launching from a ship as well. And so while the airplane was being established on station, Mark's team was able to successfully launch the WAM-V autonomous vehicle from the harbor. It's important to note that these systems have multiple payloads involved or installed in them, and so that even when they're on a, dare I say, a counter illegal fishing patrol, the opportunity exists to service multiple requirements. In this case, the WAM-V had a multi-beam sonar that was operated remotely during the illegal fishing, collecting high fidelity bathymetry. As I mentioned before, it's really important to support both tactical decision-making as well as the strategic or the legal proceedings. So in this example, we were able to disseminate the information live and in near real time to anybody with a smartphone, a tablet, or a computer. In this, we tied an action, in this case fishing, with a location depicted on the map in the conservation area, with a time. So being able to tie an activity, a location, and a time, that spatial temporal, we think is critical for both tactical decision-making as well as strategic, dare I say, court convictions, actually. We were able to see a number of modalities of fishing, all potential demonstrations of illegal fishing. In this case, a spear gun and a spear fisherman being pulled out of the water, or sport fishermen with lines in the water here. Or in this case, a paddle boater trolling off the coast of Dana Point there. So again, the intent here is to collect this information and then secure it in such a way that it is usable in a court of law. And then at the end of a very successful demonstration, both the WAM-V as well as the airplane returned to shore in an effort to support future operations. And obviously, this is an ideal version of a littoral type fishery, but where we would like to take this is a full integration for those open sea fishing, counter illegal fishing operations. Next slide. Yes, please.
Okay, so now I want to talk a little bit about the actual collection of the information and sending it back to shore or to wherever you eventually want that information to end. So when we're talking about IUU operations, it could be that we need the information to go back to shore. It could be that we need it to go back to a ship that's supporting the effort. But long story short, you need to get that information back, this actionable information that law enforcement can use to intercept or to plan to intercept the vessel that's fishing illegally. So again, it's important that that information is encrypted. It's for our network that we used. It was a mesh network, so that all the vehicles were talking to each other and back to the ground control station, which you see in this image. That ground control station could obviously be on a ship. We could also obviously pass it via satellite comms as well, depending on where it is. The important thing, of course, again, is collecting that visual information, and that's really what we just demonstrated in this effort, was to show what was happening and exactly where it was happening, right? So that at the end of the day, the folks that are going after these people have the information they need to prosecute them in court. Next slide, please. And let's go back to Chase.
Thanks. As Mark said, it's a combination of secure chain of custody as well as aiding decision makers and enforcement and interdiction teams in the field. And so we just wanted to highlight some of the capabilities that these autonomous systems provide in terms of displaying all the information collected in an easy to use and easy to run format. So in this case, the video from the airborne asset is in the top left. The video from the WAM-V is in the bottom left, and that information is overlaid in a map, a completely user interactive map on the right-hand side. We also have AIS receivers installed in both the aircraft and on the WAM-V, and so we can depict other vessels in the area to aid in that situational awareness. Important to note that the video being pulled off the airborne asset is geo-rectified, and it's geo-rectified down to within about a meter. We advertise 1 to 2 meters of resolution for that. We can also see where the WAM-V was in this particular instance, and then you can see exactly top center the time at which the user was looking at this web application, and compare that to exactly when the video was recorded by looking at the time in the bottom right-hand side of the airborne asset. In this case, it's near real time. We were about 4 seconds latent, but that 4 seconds was pushed from the operation in Dana Point, California, and being received on the East Coast. Next slide, please. I'll turn this back over to Mark.
Yeah, okay, so as we're talking about the next steps, right, we're really, as Chase mentioned earlier, we're really looking at long endurance operations. When we're talking about places like Palau, we're talking about the Northwest Hawaiian Islands. We want to bring on, the UAS onto a larger WAM-V so that we can scale the operations to cover thousands of miles. The aircraft itself has around, I believe it's around 16 hours of endurance. And if we put it on a larger WAM-V in the order of about 50 to 60 feet, we start talking about 3,000 plus nautical mile range. And that's really what we see kind of going forward for these remote locations. Turn it back to Chase, please.
And when we look at these long, large blue water areas, it's important to realize that we have to optimize both the vehicle and the payload for those types of environments. The sensor that we flew over Dana Point is perfect for a littoral type illegal fishing patrol. But when you ask an operator to survey thousands and thousands of square miles of open ocean, that's not always conducive to an effective search, wide area survey. And there are sensors out there that can be integrated into both the WAM-V as well as the airplane, which we think can help support that. And then the other important piece of moving forward is being able to use and understand that data. Data off of collectors is really only as good as it is current and relevant. And so being able to pull data in real time is going to be critically important moving forward. And there are a bunch of brilliant minds and companies on this problem, but I see that real-time data dissemination, whether it's satellite-based, like a Starlink system, whether it's blended multi-SIM, multi-cell phone LTE services, like some of the companies are working on. There are numerous options, but we need to be able to commercialize that data backhaul and dissemination. Next slide, please. Over to Mark.
Great, thank you. So I'll run through this pretty quick in the interest of time. So you asked, why the WAM-V? Some of the key advantages to the WAM-V technology is the stability of the vessel, right? So when you start talking about launching aircraft, launching underwater vehicles, putting sensors in the water that need a stable platform, that's really where the WAM-V shines. And another advantage of the WAM-V is the modular aspect. So you can swap out components easily. You can swap out payloads easily. For maintenance items, it's easy to swap out. For example, the back engine pods, you could swap out. You could have a third engine pod and rotate that in for service. And then also the scalability of the design. We build them anywhere from 2.5 meters to the largest one to date was a 30-meter variant. And we have designs for a 40-meter variant as well. Next slide, please. Again, here's just a few examples from the smallest one being the 2.5-meter variant up to the 30-meter variant, the WAM-V 100, which had a 5,000 nautical mile range. Next slide, please, and back to Chase.
And from the Overwatch Aero perspective, we are supporting these operations with a Latitude FBR-90 unmanned system. We like this system because it flies for a long time and it flies high. So we're able to, dependent upon the payload, fly up to about 24 hours per operational sortie and up to 18,000 feet, which allows us an opportunity to find that sweet spot for long endurance data collection. With the mesh networked IP configured radios that we have, we're able to reach out about 50 nautical miles from any given node. So if we were to put a node on the WAM-V, for example, and then have a satellite data backhaul, we could control the airplane and the WAM-V via that satellite and have an additional 50 nautical miles from that WAM-V. The other awesome part about this airplane is that it has a modular payload bay. So we can carry about 22 pounds in the nose as well as some additional weight and then hard points in different locations throughout the airframe. And we currently have a Trillium HD80 installed, which is a combination daytime TV and thermal infrared camera with accuracy, like I said, down to about 1 to 2 meters. We also had a VHF, UHF, and P25 communications relay installed for this. We found that it could be beneficial to be able to hail a boat on channel 16, for example, and have a two-way conversation. And then, as we mentioned earlier, there are possibilities for AIS receivers on the airframe as well. Next slide, please. And with that, we'd like to thank you very much for your time and turn it back over to Allison.
All right. That was really interesting. Thank you so much, Mark and Chase. Next up is Rich Hines from ThayerMahan. Rich?
Thank you, Allison, and thanks for our host today for putting together this topic and presentation. My name is Richard Hine. I'm the Chief Operating Officer and co-founder of a company called ThayerMahan. We're a 5-year-old company located in Groton, Connecticut. Next slide, please. We were founded by myself and my co-founder, who was the retired Vice Admiral Mike Connor, who was commander of the submarine force. When he retired, him and I were shipmates back in the 80s. And one of the things Mike realized late in his career was the future of ASW, in particular, anti-submarine warfare, depended on the implementation of large amounts of inexpensive, distributed, autonomous systems and sensors. Back in the 80s, the height of the Cold War, the U.S. submarine force had 180 submarines. Now we have about 65. We had one threat, basically the Russians. Now we have multiple threats all over the world. So we embarked on this, launching this company with a focus on ASW, using precision acoustic sensors on energy harvesting autonomous vehicles to combat and augment the Navy's use of large submarines and attack submarines for ASW. Next slide, please. That over the course of a couple years, that technology scope broadened into three, I'll say two major areas, what we call persistent surveillance systems, which is our Outpost and our Sea-Watch system, and our seabed group, which is our Sea Scout system. Very briefly, Outpost is a state-of-the-art acoustic sensor that is platform agnostic. It can be deployed from virtually any USW that is capable of towing a sensor at about 400 feet of depth and with a sensor length of 200 to 1,000 feet long. The longer the array, the longer the acoustic aperture, the better the detection ranges for various sensitive targets. It's been successfully tested for the U.S. Navy, deployed by U.S. Southcom and JIATF on counter-drug missions. TRL level is 8, and we're now shifting to employing our patented classifier system in targeting IUU fishing. Second system of note today is our Sea-Watch system. Again, it's a platform-agnostic electronic warfare suite capable of detecting and reporting in real time VHF, HF, and other communication bands of interest. All of this information is brought back to our 24/7, 365 Ops Center located in Groton, Connecticut, and dispersed via our cloud-based architecture to any of our clients in any format, be it secure comms or unsecure comms that is requested. The third system, which is noted there, is our Sea Scout, and that's precision seabed imagery using synthetic aperture sonar, which I won't discuss today. Next slide, please. So the sectors we serve, we have a good-sized presence in both military intel, homeland security. We're now involved with both offshore energy and inspecting undersea infrastructure with our seabed system, but also on the acoustic side, we are monitoring for the North Atlantic right whale and other marine mammals of interest. And then we just recently acquired a company that gives us superior footprint in ocean sciences and acoustic sciences. Next slide. So basically ours is a search as a service business model. We're the way we've operated in the past is either government-owned or contractor-owned systems with contractor operations. This minimizes the amount of investment that the Coast Guard or Navy has to put in developing rates and training programs and putting personnel. So we get paid only for systems that are at sea reporting information. Next slide, please. So the fishing problem is kind of uniquely situated for our acoustic sensors. I'm not going to talk about how important it is. I think we're all aware of that and the amount of losses, but the difficulty in monitoring remote locations, large areas for long amounts of time, and just the general maritime domain awareness problem that the Coast Guard and other enforcement agencies have is vast. And the only way to tackle that, frankly, is with autonomous systems. And our acoustic system and RF system, we think, are part of a larger solution that my co-presenters, Chase and Mark, discussed as well. We have long detection ranges. We can localize, provide tipping and queuing over many, many miles. We can stay at sea for 90 to 180 days continuously. Since our vehicles are energy harvesting and low power, and we report all our information real time with about a 5-minute latency rate back to our command center for immediate distribution to our clients. Next slide, please. So can you really assess fishing activity using acoustics? historically, it's been a survival skill for the submarine force to be able to detect, localize, and track fishermen and trawlers, because we generally operate in and near ports that have a lot of fishing activity. Back in the 80s, there are a couple of publicly reported events that when things have gone wrong for submarines where they didn't notice a trawler or whatever, and dragging a trawler through the water for a number of miles is both dangerous and expensive to repair. Next slide, please. So the submarine, acoustically, we try to do three basic things. We can identify the fishing vessel based on acoustic signatures. So how is that done? By doing an engine analysis, a screw bait analysis, auxiliary system analysis, and transient analysis. All that's done acoustically. We have a team of 7 retired ACINT specialists from the Navy. Think about Jonesy for the Hunt for Red October. We got a bunch of Jonesies on our staff. Localizing a vessel, again, is something we can determine range. We can do target motion analysis, which is basically using the maneuvering of our sensor and changed orientation of the array to determine course, speed, and range of our target of interest. Also, using our Sea-Watch system, we can cross-correlate between radio traffic or EW traffic and acoustic traffic to give a precise location, speed, course. And then also to determine if they're doing actual fishing activities. Transient analysis means the starting and stopping of winches, the dragging of nets on the bottom, throwing gear over the side. All that is very, very noisy. If you think about as a kid, sitting in the swimming pool or at the beach and putting your head underwater and banging a couple rocks together, sound travels long distances in the ocean, and with the right sensors and science employed, it's easy to detect and analyze, and that's what we specialize in doing. Next slide, please. Next slide, please. So basic sonar course, there's 2 types of sound, broadband and narrowband, which is represented in our display in the upper right. If you think about a symphony orchestra, broadband would be all the sounds and frequencies coming from that orchestra. Narrowband would be specifically listening to, say, the first clarinet amidst that orchestra. So using broadband and narrowband, we can localize vessels, we can determine track, course speed, etc. And we can do this at great distances, which I'll talk about in a bit. Identifying the vessels is something we do using mostly narrowband information. So every pump on a ship emits specific frequencies, propellers based on their screw blade configuration, the number of shafts, the reduction gear ratio. All of that we can determine using narrowband analysis, and that's how we specifically identify vessels. And once we determine a ship's acoustic signature, which is unique for every vessel, it's kind of like a fingerprint. When you have an acoustic signature programmed into your classifiers and you start building a history of illegal fishing vessel, it gets even easier to identify them on subsequent missions. Next slide, please. So the Outpost is an autonomous low observable energy harvesting deep water acoustic sensing system composed of a host vehicle. In the pictured case here is a liquid robotics wave glider, but there are we've tested off other sensors or other platforms, and we have a new next generation USV that we're in sea trials right now that we've partnered with Raytheon in the development of, which has overcome some of the challenges that a wave glider poses, being that it's slow and it's subject to severe currents. It gets difficult to operate, and also it's limited. We're limited to about a 20-watt overall power budget. Our new system called ThayerMahan gives us about 1,000 watts to work with. And Sea-Watch is the same way. It's an RF system, RF intercept system. It's platform agnostic. All our sensors are platform agnostic. We just need power and GPS from the host vehicle. Next slide, please. So this is a conceptual diagram of how an acoustic detection system works. So you'll see in this diagram, you'll see the ThayerCat, which is the black and white catamaran looking vessel to the left. And you'll see a wave glider over on the right near the Coast Guard vessel. And represented in the drawings is a trawler and also a transshipment activity. So all the detection information, our arrays are, again, about 400 feet underwater. We can hear all these different transients. We can hear engines, et cetera. That information is transmitted continuously via satellite back to our ops center, which you see pictured on the left, for dissemination to whoever our customers may be, law enforcement, Coast Guard, or partner nations. Next slide. So this, I apologize, I realized the slide got cut off a little bit, but if you start down in the lower right, it pictures a couple of illegal fishing vessels. This is the cycle of execution. Our systems would detect either RF or acoustic traffic, report via satellite. Our entire business is hosted in the Amazon Gov Cloud, so we have secure for classified government operations as well as non-classified operations back to our ops center. The information is processed via our automatic classifiers, which are proprietary acoustic identifiers of vessels based on acoustic signatures. We also do human analysis as well, so we have a human on the loop as well, our sonar analyst, and then that information is reported in either a 9-line format or any conventional format that our host client looks for and sent to the interdiction asset at sea. Next slide. So this is just a typical in the Caribbean basin, how it would be. That's the Puerto Rico in the upper right and the Dominican Republic. So this shows basically 10 outposts deployed with a nominal detection radius of about 60 kilometers. Depending on the physical oceanography, that can be much longer. Things like the sound velocity profile of the water, the bottom type, and the depth of water all play into whether we can get bottom bounce and convergence zone detections, which can go at significantly longer ranges than depicted there. Next slide, please. A typical laydown in an area of interest between the Galapagos and the coast of Ecuador. Next slide. And this is our ThayerCat, which is a new vehicle. It's been sea trialed already. We're doing final testing and sensorization, available in 2021. Improved endurance, speed, power capacity. We're also integrating optical sensors and our RF package, so multi-sensors on one vehicle. And we're continuing to improve our AI for automatic target detection and classification. Next slide, please. And these are just kind of a summary of things I talked about. So in the interest of time, we'll just move on. Next slide. And that's my contact information. So back to Allison. Thank you. Yeah, I could take a stab at that if you'd like. A lot of the illegal fishing activities, and on a couple of those slides I showed in the Central Caribbean and off the coast of South America in the Galapagos region, where illegal fishing is going on in a large scale, is also an area where known trafficking of drugs and human trafficking and other illicit contraband. So we've done a bunch of counter drug missions for Coast Guard and GIATF, and we do see kind of a multi-mission capability for both sensor suites, whether it's the one I talked about or my co-presenters talked about. You're not going to be limited to just detecting IUU fishing. So I don't know that any of the three of us are fish species experts or marine biologists, so that might be a tough one. I can tell you that monitoring of marine mammals is a technology and something that we do regularly. So acoustically, marine mammals make very specific vocalizations. So on the east coast of the U.S., we've been specifically interested in targeting for analysis and tracking the North Atlantic right whale, which is endangered. But we can also detect sei whales and finbacks, sperm whales, etc. But as to which fish have suffered the most, I'll see if Mark or Chase has any commentary on that, because I certainly do not.
Yeah, I would say, unfortunately, I'm not the expert in the fisheries as well.
Can you guys hear me? Okay. Oh, okay.
Okay, so yeah, that's a good question. So
I'm
we're
sorry.
currently operating in about 10 countries with the WAMV, and much like I would say with drones and with autonomous vehicles in general, it's kind of a it's an incremental step, right, to just being comfortable with new technologies as they come, especially autonomous technologies. So as our vehicles do more and more work, whether it's out doing hydrographic survey work, doing autonomous research and development, or doing other types of surveys, I think that's a key part of just local adoption and just people overall getting comfortable with these new technologies, these new autonomous technologies.
I would just throw in that Mark and Chase and I seem to show up on a couple of these panels, and I think I would take a leap that I speak for all of us that these systems, whether they're airborne or powered systems or energy harvesting or acoustic, are all part of this whole tipping and queuing um, uh, array of systems that can be used to combat illegal fishing. I don't think one technology can solve this problem, but I think a combination of various technologies and sensors coming at it different from different angles and so to speak, in different types of experience would serve well for the Coast Guard and other enforcement agencies to invest in.
I wholeheartedly agree. I think that at the end of the day, any interdiction or legal prosecution efforts are absolutely 100% going to require humans in the loop. And I think that I see these sensors, the multi-domain, the air, the surface, and the subsurface, as well as all the different sensor capabilities as that tipping and queuing, the triggering action to potentially is, one of Richard's sensors, and then the WAMV and the airplane go and interact for a longer endurance, collect on them, and then all of that information is passed to legal authorities. So I 100% agree that sensors and unmanned systems are absolutely a huge part of it, but it's going to still require humans in the loop in order to execute based on that tipping and queuing and that multi-int collect.
Yeah, I agree, and I'd add, I know those of us on the panel, and I'm sure a lot of the audience realize the scale of the problem, and we're talking about some massive areas that are going to require a lot of sensors out there to really target this illegal activity, to document it, and to make sure we get the information to the proper authorities so that they can actually go after these folks and make a real difference. Thank you, everybody.
Thank you.
Hello and welcome to the plastics panel. My name is Jennifer Brandon and I'm a senior scientist at Applied Ocean Sciences here in San Diego. And we are a company where we get the best science into the hands of the people solving the ocean's hardest problems. I personally am a biological oceanographer who's been studying microplastics for the past 8 years, and I'm excited to chair this panel on marine plastics today. So today we'll hear from 5 speakers who will each briefly introduce themselves and their organizations in about a 5-minute presentation, and then I'll convene us for some questions and answers at the end. So we're going to have the speakers present themselves in alphabetical order and just go one from one to the other. So we'll start with Brian Bauer from Resynergi, which is a plastic to fuel company. Then Anna Carvalho from FullCycle, which is a company focused on the circular economy and recycling marine plastics. Then Phil Johnston from AutoNaut, which is an uncrewed surface vessel that is involved in environmental monitoring. Then Kim-Ashleigh Mostert-Freiberg from Clear Blue Sea, which is a debris cleanup robot prototype. And finally, Matthias Oppliger from Tide, which is a supplier of ocean-bound plastic waste that can be upcycled into the supply chain. So we will start with Brian.
Okay. So what I'll do is I'll update a lot of our partnerships because this is all about a very huge problem that a lot of people need to address. And so not any one person can handle it all, but we're definitely doing our part. And the big driver here is creating value of plastics to motivate people to clean the ocean. So that's one of our angles. So next slide. So what we do is we make a system that takes waste plastic and we convert that into diesel fuel or back into plastic, again, working with partners. But imagine you can put that anywhere in the world at any scale. So you can go right to the source of the plastic and process it right in place and do that profitably. So that's the key, is to scale down and to scale up and be profitable all along the way. So wherever you deploy, you're motivating individuals to actually recycle and reprocess. Next. So what we do in the simplest form is we take the waste plastic, we chip it, and then our advantage is we use a microwave technology to do a fast pyrolysis. And pyrolysis is in the absence of oxygen, so you're not burning, you're not incinerating. It's much cleaner than incinerating. So that's a real important distinction. Ours versus other pyrolysis were very fast, so they were very compact, very small. That's what allows us to be very agile and scale up and down. But what we do after we gasify in the reactor is we convert that depending on which catalyst we use, we convert that into diesel fuel or into naphtha, which gets repolymerized back into plastic again. So that allows you to do really clean plastics, food grade and high tolerance plastic manufacturing. Next. So again, we are modular and compact. That shows us in a 20-foot container, our 1 ton per day processing unit. We have a 5 ton, which is the first real product to be deployed and be profitable. Our advantage, again, one is modular, the other is be all electric. So we can use clean energy sources and monitor very well. A very efficient process. And then we can monitor that well with electricity. And then we can also, as I mentioned, the modular style of things in the bottom left there, you see how we can, much like a daisy chain of a Tesla battery module set, we do the same thing as we scale up. But we can deploy on small boats, islands, and we'll talk about how we're partnering with ocean cleanup here in a bit. Next. The 3 outputs, I mentioned fuel. It's very low sulfur fuel. We are much, much cleaner, of course, than bunker fuel, but then also versus regular road fuel, we have no sulfur in our output. The other 2 products, we've teamed with a number of large chemical suppliers, chemical companies that are trying to recycle as much as possible, up to 30% of what they produce, manufacture, and put out. They're aiming by 2030 to have that recycled and not deriving from drilling. So that's our repolymerization. And then all of our fuels, sort of the fuel categories, energy in general, fuel boilers, steam generators, all kinds of generators. Next. So that's our actual system. The reactor in the center there, that is the microwave system, and we're basically multiplying that in modules, 5-ton modules, and scaling horizontally. But we have a team. We've teamed with Recology in Santa Rosa, and 8 other post-industrial manufacturers that have plastic waste, and so it's a really nice post-consumer waste, post-industrial waste, and then also some ocean plastic coming into that pilot site. So good results there. All of our targets for efficiency we are hitting, and our yields are very good. So we get about 3 times more economic value than the energy that is put into it. Next. So how do we work with the whole world? There's a lot of people who play, and this is the waste pyramid. We all want to reduce, reuse, and recycle, and then avoid landfill and incineration whenever possible. So next slide just shows there's recycling mechanically and recycling chemically. Chemically is much cleaner. I mean, it's much more usable plastic. Don't always need to do chemical, but next slide shows right where we play on both the chemical and the energy. So we do everything. We agree with all the partners who want to replace plastic with other materials and so forth. We play there to avoid landfill and incineration. Next. So briefly on a couple projects that we have going. When we look at collection partners, their responsibility is to collect. We will take it from there. So if they take everything that they get, we can work with our sorting partners and our PET recycling partners, and we will recycle the other stuff, the 2,4,5, which is the polyethylenes and polypropylenes. We're teamed right now with Recology on land. So we want to avoid plastics even getting into the rivers in the first place, and avoid the river plastic getting into the ocean, which we all know is the source of most of the ocean plastic is coming through the rivers. So we've teamed with people like Clean River, and then on the oceans with Voyages Institute, Ocean Voyages Institute, that's Mary Crowley, who spoke last year. We did a big project this year. Next slide. One project we're looking at right now is the island of Hawaii, another one in Indonesia, where basically most of the plastic that's wasted and can be collected is coming from the land. And as much as we bring, and it seems like a lot from the ocean, it's a small percentage. The good thing about that is it's very profitable to turn the plastic into fuel or naphtha. And that allows us to actually somewhat pay for the ocean plastic cleanup. So that's the goal in most of the projects. Next. So this is just some pictures from that actual cleanout this spring and summer with Mary Crowley. 340,000 pounds, 150 tons was pulled out from the big gyre between Hawaii and California. We plan to do a whole lot more in the future, and right now we're working on the feasibility of exactly how to chop that up and how much is nylon versus polyethylene, but it looks very feasible. Next. A bigger project, I'll just briefly go through this, bringing ocean plastic from people like the Ocean Voyages Institute, and then the land plastic. Okay, we talked about that delineation. We take it with our partners, sort, wash, granulate. This particular project, we put out both naphtha and diesel fuel. So diesel we can use for electricity generation. We also put out heat, and the generator puts out heat. And that's with a system like the forward osmosis unit Trevi systems. They take that and it makes them more efficient. And then they feed us water that actually helps us clean the plastic, because we don't like salt to go into our system very much. So it helps a lot to have a desalination unit if it's right on the boat or right on the shoreline to do that. So it's a nice circle of partners here that helps the efficiency and the overall effectiveness. So next slide. I'm not going to go through all this, but these are like the speeds and feeds and outputs of a 5-ton system. And then the next slide is for the 20-ton system. Larger numbers. We would in this case we'd put two tons out to fuel the diesel for the forward osmosis unit, and 14 tons out for naphtha, which is very profitable. Next slide. And so the revenue for overall 20-ton per day unit is about $6 million. And we aim, depends on the price of fuel and electricity, but we aim for a 10 to 30% return on that. So it's a very nice, one system's great, but all these working together is fantastic. Next. This last slide here is this is a nice benefit on top of the profitability, is looking at carbon credits. And what's come, the Ellen MacArthur Foundation has started a program looking at plastic credits. So plastics that are diverted from landfill and are recycled. We're looking at plastic credits in the future. So stay tuned for more information on both of these kinds of credits and the world working together on this. Thanks. That's all I have, and look forward to discussing.
All right, next. Sorry. Next is Anna Carvalho. FullCycle.
Hello, good afternoon to all. So my name is Anna Carvalho. I'm a professor at the university and also the co-founder of FullCycle. So FullCycle is a company that aims to create circular economy solutions. Please, next. And so basically our mission is to create a better world through waste valorization using state-of-the-art technology and trying to empower, whenever it's possible, the local communities and creating circular economy solutions worldwide. Next, please. And since we are always aware of what are the major problems in the world, ocean plastic waste, it's one of them. Of course, we all know that, that's why we are here. So 8 million tons of plastic waste ends up in the ocean every year. And this plastic waste is killing and it's injuring a lot of marine species. So basically we need to do something. So FullCycle was aware of this and need to do something. Next, please. And this is what we did. So basically we started to do a link between different stakeholders that could create a value chain that could act from the cleanup until the products at the final market. And we have created a value chain together with other partners that are able to clean the beach, the riversides, also collecting the fishing gears from the harbors, transforming the plastic waste into recycled pellets, redesign and create new products that can be put into the market and valorize the ocean plastic waste, and also creating these in an industrial scale, which also allows after the end use of the final customer to recycle again and to generate new products again. Next, please. So what do exactly FullCycle does in this value chain? So we are a player, we are the one that potentiates this collaboration among the players. We do research, mechanical tests, chemical tests to the plastic waste from the ocean to ensure the quality of the products. We also do the design and redesign of products in order to put them into the market. And we help also in terms of communication and how this can improve the environmental impacts and also the sustainable development goals. Please, next. So some examples of some of the products that we have developed. Next. So with this COVID situation, in 1 month, we were putting these 2 products into the market. So one was one face shield, that this front part with the frame is from the RPP from the oceans. And the other one is the ear savers, where you put there in the back so that you cannot put the bands in your ear. So you can put the bands in the ear savers. These 2 products were designed and were produced at a large scale and put into the market in 1 month, as I said, due to the partnership that we have done with our partners. So I would like to thank them, the Green Wave Plastics, WFO Plastics, and also Farmy. So all together, we were able to put this very fast into the market. Next, please. We helped with the communication of these face shields. So we always want to put the products into the market with information to the customer so that they know what they are promoting. So we tell them that they are reducing the plastic from the consumption of virgin plastic. They are also promoting the recovery of more plastic from the ocean. And also, we also like to tell what the client and the customer is achieving in terms of the sustainable development goals. So we also do this, and we put this in our flyers when we distribute these products. Next, please. We are developing different new products with different types of technology. So by injection molding, We are doing now some wheels that we are integrating in toys and shopping carts. Also with the blow molded technology, we are doing using the RHDPE containers, doing these containers that can be used for recovering of some waste or as toolkits. Also, we are using the technology of roto-molded with the RHDPE to create bins and some furniture for outdoors, all with the ocean plastic. Next, please. So what FullCycle aims is to create this cycle from the beginning of the recovery from the plastic of the ocean, giving a new life, and then being able to recycle these products over and over. So what we want is that the plastic comes from the ocean to the house of the consumer, creating a new life and contributing to the ocean plastic reclaim and reducing for the further the pollution. So next, if you have any question or if you would like to know more about this project or other projects that we are developing, please feel free and contact us. Thank you very much.
Thank you. Thank you. All right, now Phil Johnston.
Sure. So I can get the slides up, that'd be grand. I can crack on. Grand, thank you very much. Well, what a start. It's great to be here, virtually, of course. So a few slides here on our role in the ocean cleanup project, which was operating the last couple of years, last couple of summers off the Pacific, out of California, between where you guys are, and Hawaii. And our role as an unmanned surface vessel, uncrewed surface vessel, as we call it now. So next slide, please. So you're probably very aware of the ocean cleanup. It's enjoyed a very high profile, thanks to the founder, Boyan Slat, there in the top left, as he puts it, I think a high school project that's got out of control. And I think it appeals to people as a can-do solution. You know, there are many approaches to this, and obviously there are many decisions we have to take. But putting a physical barrier like this out in the ocean to physically collect the macroplastic that's already out there at the surface is a very appealing one. It's galvanized the public and the government. So we were very proud to play a small role in it. Next slide, please. So our role came at the testing stage of both the system and our own system, really. So putting the barrier out there, there'd been tests previously in the North Sea and a lot of modelling work, a lot of preparatory work. But putting out such a novel technology out in the Pacific was no mean thing. So the initial run of missions was threefold aims, really. Really to understand how the system was going to behave and how it interacts in environments. Secondly, to ensure that any environmental impact it had was going to be closely monitored and minimised. And finally, this is a little studied area, so to acquire data as best we could. And we weren't the only bit of technology in the mix for this. There were others as well. So we had the Ocean Cleanup ran aerial flights with aerial drones, also dye tests and GPS drifters, Pacific drift buoys more for looking for marine mammals in the area to assess what the population level was, and visual marine life monitoring for something similar. But a lot of this was really to do with understanding how the ocean was moving, how the plastics was moving, the surface was moving, and how that was interacting with the plastic, with the plastic collecting barrier. The concept, has been, well, this idea is a sort of a collecting a mouth, Pac-Man, if you remember that, to physically kind of chase the plastic down, or would it sit back and the plastic would come into it? But that was the big ambition. So our role, if we go to the next slide, please, was to accompany the system, which is lovingly called Wilson System 001 in the first iteration, and we were very proud to accompany that with a USV that's also endurance. If these systems are going to stay out there for weeks and months, then something to accompany it, to keep an eye on it, to check the asset integrity, and to collect science data was deemed as extremely valuable. So this is our boat. It was proud of our fleet at the time, and a beautiful colour as well, thanks to the Ocean Cleanup livery. It's not small, it's not big, 5 meters long, and it's wave propelled. So the key element to it is that it is renewably powered, and it will stay there for many weeks. Next slide, please. And here are the missions we did. We did start off with a boat called Isla, a USV called Isla, before moving to Eve. And ramped up our sea time, and this is a big deal for us. We've since gone on to do other endurance missions, but there are a lot of USVs out there now. But those with proven sea time, that's the big test. These are marine systems that need to work in a tough environment. So we're very pleased to work up to 50 days accompanying Wilson out there in the Pacific. And you can see from their map what just sort of in the general area of where it is, long way out. We did have a research vessel with us, a conventional vessel, I should say, from Maersk that was deploying the Wilson system and also obviously housed the crew to conduct the tests. Next slide, please. So I think I've got to run a slide here, so I'll try and be brisk. Our first role really in the AutoNaut was to inspect the barrier system itself with subsea camera systems and also the surface and relay that back to the vessel. But actually, if we go to the next slide, please. We find we had a secondary role, thank you, second role of spotting marine life and litter beneath the waves as well, the crystal, clear water zone in the Pacific. So that it had a second role which took on its own life of its own, really. So you can see a turtle eyeballing the AutoNaut subsea camera there, and a few other creatures in the mix. But I'll rattle through to the next one. You can see the clock working its way down as ever. Wind and wave. I'd love to go through this, but I think we're going to run out of time. But these are some of the data that we had, and those oceanographers amongst you all know that it's a very complex system. How the ocean moves around, how the surface currents move around, of course how the plastic moves around. Understanding how that works and how the barrier is going to perform was a real big driver, and of course the USV is a neat platform to collect that information. This is sample data shown here, and a lot of that has been the analysis has been run by the Ocean Cleanup. And they've published some interim results, and I'm sure we'll follow in due course. And it backed up a lot of the modelling. The key element, I think, in all this is collecting the data in an understudied area where there weren't not that many reference points, and not much physical measurements gone on otherwise. Next slide, please. Oceanographic data, of course, simple stuff, but no less important for that. Temperature, salinity, conductivity, chlorophyll, all useful stuff. And again, you're looking to reference the models, and you're looking to build the work that's already been done in an understudied area. But, next slide, please. And ADCP. So this is a good development. More conscious that with a lot of technology content in my presentation, but developing ADCP to fit on USV to assess the movement of the ocean currents was a key understanding, and that was some technical implications which I'm happy to unpack if anyone's of interest, takes interest in it. But moving on, I think moving towards the next slide. Another more technical development, but this was track follow the system. But other than that, happy to say now it's okay. Next slide, please. I can see my timer is basically up. Just a quick thank you also to update on the ocean cleanup itself. They've initiated a river cleanup system and deployed that in a few rivers around the world, and also have made their first products from the plastic collected from the ocean, recycled into very nice sunglasses, which are available to a lucky few. Other than that, thank you.
Thank you. All right, Kim-Ashleigh, thank you.
Hello, everyone. My name is Kim-Ashleigh. I'm a program manager, at Clear Blue Sea. Next slide, please. So like everyone's talked about, our big problem is ocean plastic. Next slide. And our solution, contributing with everybody else, we all have to work together for this problem, is FRED, floating robot for eliminating debris. Next slide, please. We like to say that FRED is a pretty simple robot. It's the ocean. That's really complicated. So you can see some of the capabilities of FRED here. It's solar powered. We envision FRED with the idea of not creating more harm for the environment. So we don't want to be contributing to more fossil fuels. It's semi-autonomous, so we can take over if need be. FRED is cool because it's really adaptable. This conceptual FRED picture you see here is for our FRED 50, for our big ocean-going FRED that's yet to be built. But we do have some of our mini FREDs, which are adaptable to rivers, bays, kind of like local waterways. And really, like I said, FRED's simple. The idea is that the plastic gets collected through the booms, goes up the conveyor belt, and then there's bins sitting in the back of FRED that collect that plastic that then just offloaded at another base. Next slide, please. This is kind of the conceptual idea for FRED moving forward. We'd ideally like to have multiple large FREDs in the ocean to clean up those patches, those gyres that everyone's talking about, and then unload at the mothership. We then plan to partner with people like Brian, I guess, to give that material to recycling sustainably. And then overall, all these FREDs are controlled by mission control. Next slide. So these are some of the FREDs that we do have. Like most of the companies, I'm sure, funding for this type of initiative is a challenge. And the way that we really get around that is to partner with schools, mostly in the San Diego area. So USD and SDSU have both built mini FREDs that you can see here, funded by Clarity and Aero Electronics. And these were two of projects that actually happened simultaneously, which is pretty fun. We gave assignments to the teams to build FRED. This was the idea, and both of them came up with their totally different design, although FRED does the same thing. And then at the bottom, we've got FRED Junior, which is about 16 foot on a donated catamaran base that can handle a bigger place like San Diego Bay. Next slide. So our goal for FRED, we're currently in phase 2. We're prototyping. Like I said, we've got a bunch of those minis. And then we hope to move into phase 3 once we're able to collect significant funding for 50-foot FRED. Next slide. I want to just mention the way Clear Blue Sea is really funded and supported is through our interns. We've had over 200 interns in our 3.5 years of being in production, almost 4. And they're really like the backbone of our drive and our innovation. Like I said, we take interns from a variety of colleges, but also high schools. And now we actually have a lot of remote interns. With COVID, of course, we've just made a lot of adjustments to be able to take interns and teach good skills from around the world. Next slide. So we had a lot of goals moving into 2021 because 2019 was our most profitable year. Some of these goals have been extended due to COVID, but our plan is to operate FRED Junior. There are the bottom slide on the right on the orange catamaran, that's FRED Junior in San Diego. And this one's actually on pace is Freddy, which is my bottom left, the gray Freddy is our do-it-yourself Freddy. The idea behind this is that we're going to create an implementation project so Freddy can be a do-it-yourself for anybody around the world. You just partner with Clear Blue Sea, receive the manual essentially, and then anyone can build their own Freddy to be adaptable to their own type of waterway. So we're hoping to roll out Freddy number 1 by December, and then hopefully early next year. And then our big goal is just to secure significant funding so that we can grow Clear Blue Sea and build FRED 50. Next slide, please. Oh, well, thank you. That is my last slide. So overall, thanks for having me. And if anyone is interested in connecting, clearbluesea.org. Thank you.
Great, thank you. All right, our last speaker is Matthias.
Yes, hello, and thank you for having me. I'm really happy to talk to you today. Next slide, please. My name is Matthias. I'm Director of Partnerships at Tide Ocean, a Swiss company which was founded for one reason. Next slide, please. Our world faces a huge problem. You all have pointed that out, but you can't stop saying that. It's really important. Next slide, please. Luckily, we have the solution. Next slide, please. We are upcycling ocean-bound plastic waste. Next. Which brands then can use for their new sustainable products. Here you can see a watch that was launched by Luminox in partnership with Bear Grylls. Next slide, please. So how do we do that? We have built a global supply chain for ocean-bound plastic. It starts, of course, with the collection, which is done through fishermen in Thailand in the Andaman Sea. Next slide, please. Who then bring that plastic waste to a social enterprise also in Thailand, where the plastic gets sorted, washed, and shredded. Next slide, please. Before it is shipped to Switzerland, here is where the actual innovation takes place. You have to imagine this plastic being exposed to salt water and sun, being very fragile and heavily damaged. We found a method to repair that damage. Next slide, please. Next. In close partnership with the polymer experts at the University of Applied Sciences, we have developed a mechanical method to recycle or upcycle the ocean-bound plastic. It's really, I want to stress the fact that it's a strictly mechanical process. We don't add any chemicals and we don't add any virgin plastic. So it is 100% ocean-bound plastic. Next slide. These are our products that we're really proud of. We have the Tide granules. You can use them for plastic injection. We have the Tide yarn, which you can use to produce high-quality polyester textiles. And then we have the Tide filament, which you can use for 3D printing. So I guess waste can be beautiful. You just have to see the value in it. Next slide, please. In our understanding, value means impact, and that's what I want to spend the second half of my time with, to show you how we have an impact on 3 different levels. Next slide, please. There's the product impact. By replacing virgin PET in your product chain with our material, you can save up to 80% of carbon emissions. Of course, recycling itself saves energy, and by closing the circle of plastic consumption, fossil resources get also preserved. Next slide, please. We do our compounding with solar power and all our transports, which are significant at the moment. We plan to change that. We compensate all of that through MyClimate. Next slide, please. Then there's the social impact. This is mainly in the form of job training and jobs we provide in Thailand. Next slide, please. Here you can see some pictures from our operations in Thailand. We pay fair wages and comply with all ethical and ecological standards. Next slide, please. Third is the environmental impact. Of course, by collecting the plastic, we help to restore water and coastal habitats. Along with our professional cleanup activities, we also organize community beach cleanups, which are quite popular. And through the implementation of the said social enterprise and the network of fishermen collecting the plastic, we help to create a resilient, locally run waste management infrastructure, which, as you all know, is key to solving the problem of plastic pollution definitively. Next slide, please. And the next slide. So in short, Tide gives plastic waste a value. We are not only selling granules, we also sell a change in perspective and ultimately a change in consumption behavior. Next slide. Thank you for listening. If you have any questions, I'm happy to answer them, and you can follow us on Instagram or on our website. Thank you very much.
Great, thank you. All right, we just have a few minutes. There are questions from the audience, which if you guys can see that, it says, what kind of collaboration can be seen between these different technologies to combat the plastic problem?
I can take this one, I guess. I kind of hinted at it. I think I'm pretty new with Clear Blue Sea, but just being here today, I'm learning a lot about all of the other partners that are even just here on this panel. And I can definitely, like, I jumped out at Brian. I think that there's a lot of ability to collaborate. Fred just picks up plastic, and there's a lot of people here like Tide and Resynergi who can do something with that plastic to put it back into the economy. I think there's a lot of collaboration. We just got to coordinate. And, everyone else can also speak to some of the partnerships that they already have. I know Resynergi mentioned a whole bunch of them.
So, Kim, you beat me to it. I was going to say I would love to work with you guys because we're both in California. We could work globally, of course. But, yeah, we're looking at setting up at different ports, California, which will probably be a discussion in the next session. But, yeah, I could see that. And also communication with Anna. A lot of what you're doing and looking at the full cycle. In some places, it makes sense to mechanically recycle, and other places to chemically recycle, and that's where I'd like to work with Matthias. We are working with, there's a company in Israel that does some chemical recycling in a different way than we do. So we definitely recommend different people depending on what makes sense, because there's a lot of ways to address it.
If I can add something, I totally agree, because I believe that we need to have a portfolio of solutions. Because even if we can put some products in the market, as Tide also does, as we do, but we always have some waste also. So there is some part that you cannot totally recycle. So what you do in the first place, that you were saying that you recover in terms of energy, etc., they just complement each other. It's just different ways that you can have, and you need to have this portfolio of solutions so that you can recover the best that you can. And this is what I would like to add.
I would love to use all that plastic we can't actually recycle and to power our trucks with it with the help of Resynergi. That would be great. Yeah. Just to really have an integrated puzzle of solutions that work together seamlessly.
Yeah, we'd love to see diesel go away eventually, but it's going to take a while. Yeah. Meanwhile, we're much, much lower carbon footprint than traditional diesel in the production. So happy to help there. But I just want to say something with Phil. Working with Mary Crowley, Ocean Voyages Institute, they've started doing a lot of tracking plastic as well. So I think you working with her might be a good thing as well. I mean, she has the world record. Their organization has the world record in taking out plastic, but it's very manual, and they're bringing in more and more technology all the time. So I think that would be a good partnership there as well.
Yeah, sounds great.
All right. This question says, I agree that plastic is a waste management problem. Are education efforts incorporated by some of your organizations? Yeah.
Yes, there are. We are collaborating with a foundation in Thailand, and they run that social enterprise we're collaborating with, but they also build schools and run courses on recycling and just building awareness of the plastic pollution problem. And we're not ourselves doing it, but our partners are doing it.
Yes, we also do. We are in a consortium where we are part of it. So we go to schools, like in the high school, and we take some technology to the kids and show them how they can do this full cycle with the plastic. So of course, in a way that it's not industrial way, but they can see. And we use more your approach, Matthias, about the filament, the 3D printing filament. So we show them how they could produce this from the plastic, the waste plastic, and then how they could produce any material for educational purpose from this waste plastic. So we do that.
Great. All right. Well, we only have 30 seconds left. Thank you guys so much for your wonderful answers and your wonderful presentations. And I think just to summarize, this is a very complicated problem. And so having people kind of working on every aspect of the solution is really important. And having some people cleaning, cleaning the ocean, some people then dealing with that plastic when it comes out of the ocean and recycling it or turning it into fuel, I think is the only answer, because for such a complicated problem, we need complicated solutions. So thank you for listening.
Thank you.
Thank you.
Great. Hello, everyone, and thank you for participating in our session called Protecting the Bottom, Creating Habitats. Today we have three amazing presenters who represent organizations and companies who are innovatively protecting the ocean while contributing to the ecosystem and the development of sustainable ways. So we're going to just start right off with Tom Birbeck from Arc Marine. So Tom, you're up.
Hi everyone, great to be here today. My name's Tom Birbeck, the CEO and co-founder of Arc Marine. Next slide, please. So my background is in commercial diving and aquaculture, so mainly the inspections and repairs of subsea aquaculture lines, but also on inshore civil projects, so installing moorings, harbour wall inspections, that type of thing. Next slide, please. But today I'm here to talk to you about Arc Marine. So we specialize in nature-inclusive design and manufacture, and we also carry out ecological monitoring services both pre and post installation of our established ecosystems. We're currently operating out of the UK, but we do have a mobile manufacturing unit which can go anywhere in the world and manufacture on site. Next slide, please. So we've all seen these pictures, the good and the bad, beautiful reefs that we've fallen in love with, but most recently the bad. Reefs that have been destroyed due to bottom trawling, pollution and overfishing. Next slide, please. What I would like to talk to you about today is the ugly. Since the 1970s, offshore energy companies such as oil and gas and telecommunications have been deploying these plastic, toxic and high CO2 riddled products to protect cables and pipelines. Now, because of the materials, marine regulators deem them as marine litter, and therefore they have to be removed at great cost to the taxpayer and the developer. Next slide, please. So for the past 5 years, Arc Marine have been developing a solution to replace this existing marine litter with a low CO2 and eco-friendly alternative. We believe there's now an opportunity for every single offshore construction project to leave a positive marine legacy and remove the hundreds of millions of dollars worth of decommissioning costs which we'll be feeling in the future. Next slide, please. So we're currently manufacturing reef cubes from anywhere from 250 millimeters weighing 15 kilos up to 1.5 meters and weighing circa around 5 tons. Next slide, please. So reef cubes are extremely modular and flexible. So we can have cubes inside cubes for added complexity, and they're also a proven nursery and spawning ground for commercial fish stocks such as this native lobster here. Because of their size and weight, they're a really good anti-trawling bottom deterrent and work 24/7 hours a day, unlike satellites or drones. Next slide, please. So their impact is obvious. Most of these reef cubes have been down less than 12 months off the coast of the UK. And starting on the left, we've got tunicates, edible crab, squid eggs, spider crabs, and lobster. So the other options compared to subsea protection materials are MPA enforcement, ecotourism such as diving, coastal defence, and we're also working on coral and mangrove plantation projects. Next slide, please. So you're probably thinking, well, how is your concrete eco-friendly if you're using Portland cement? So for the past 4 or 5 years, we've been developing our own alternative to Portland cement, and our reef cubes are also made up of 98% recycled materials from clay and quarry mining industries. So from the point of manufacture, reef cubes are now completely carbon neutral by integrating carbon capture materials. Next slide, please. So we're already selling reef cubes into pilot projects. One of them is part of the Aquaculture Seafood Innovation Fund, funded by CFAS and DEFRA. That's an 18-month project looking at the enhancement of an aquaculture site using reef cubes. Secondly, we're selling reef cubes into a pilot project in Holland called De Richter Noordzee, which is a pioneering project about deploying reef cubes around an offshore wind farm, and also in the European Offshore Wind Deployment Centre based in Aberdeen around a Vattenfall site. We currently don't have any oil and gas projects lined up, but we are speaking to the Oil and Gas Technology Centre about potential pilots. Next slide, please. So all of these blue chip companies are likely to be our clients. Firstly, to remove the decommissioning costs, which I've mentioned, but most recently we're seeing to obtain a license to operate and generate offshore wind, you're having to show a net biodiversity gain in the area that you're building. There's also key drivers to go carbon net zero, and also to remove plastic pollution altogether from the supply chain and stop deploying on the seabed. We believe that there's going to be a big shift during the energy transition for companies like we see on the right-hand side to leave a positive marine legacy in their projects. Next slide, please. So here I'm showing you one of our offshore energy reefs, which is going down this side of Christmas, hopefully around a tenant substation. So this has been designed carefully with a ecologist company to cater specifically for a breeding and nursery ground for sharks, rays, and cephalopods. And we're going to have 12 of these units going down, and they weigh approximately 6 to 7 ton. Next slide, please. The most long-term project that we have at the moment is Project Refast. This is on the coast of England. It's been going over 18 months, and that's to improve the co-location of aquaculture farmers and traditional fishers by using reef cubes as the building block of the ocean. So we've got 3 scientific papers which we published to the scientific community and be peer-reviewed. One of them is to prove that reef cubes boost commercial fish stocks such as crab, lobster, and bass. The other is to improve biodiversity in the area as a whole, and the second is to show that reef cubes improve the spawning in nursery ground of juvenile fish. Next slide, please. So we've also been pioneering unmanned surveying of artificial reefs in the UK. We've teamed up with the University of Plymouth and used their USV, and what we see is this is going to be a really low cost and efficient way of monitoring artificial reefs as time goes on and limiting man hours. Next slide, please. So I mentioned myself, Tom Birbeck. I'm also joined by my CTO and co-founder, another commercial diver, but we've also managed to attract some of the top bodies in oil and gas over to our side to help us break into the offshore energy market. And we've also got 60% of our team are made up of marine scientists, so marine biologists, oceanographers, and marine biologists. So we hope in the future that we'll be able to offer a full suite of services, and we pride ourselves on being a science-driven company and pioneering nature-inclusive design. Next slide, please. So that's it from me. We're really keen to hear anyone if you've got any potential projects, partnerships, and as a startup, we were looking to do a Series A round in early 2021. Thank you.
Thank you, Tom. Really great. Okay, Eliza Harrison is next from Ocean Rainforest.
Absolutely. Thank you, Jen. Thank you all so much for allowing me to contribute this morning to our presentation. As Jen said, my name is Eliza Harrison, and I work as the Business Development Coordinator for Ocean Rainforest. Ocean Rainforest is a company that's based both in the United States as well as in the Faroe Islands, specifically focused on sustainable offshore seaweed cultivation. Next slide, please. Before diving too deeply into our work this morning, though, I thought it would be helpful to give a background in terms of why we are interested in seaweed as a potential way to support the health of marine ecosystems and our larger environment. And that is because seaweed is among the most highly valuable yet underutilized resources on the planet. Seaweed in and of itself can support a number of the UN Sustainable Development Goals. By growing seaweed, both in cultivated structures as well as by supporting the development and continuation of kelp forests worldwide, we have the opportunity to require no land, fertilizer, or fresh water. Instead, seaweed actually removes significant amount of excess nutrients from the marine environment. Seaweed has also been shown to be one of the most effective primary producers at removing carbon dioxide, therefore making it an effective strategy to mitigate the effects of climate change. And finally, seaweed has the opportunity to support the creation of habitats in local marine environments by providing a place for shelter, nursery grounds, as well as food for a variety of marine organisms. Next slide, please. In spite of its incredible environmental, social, and economic potential, however, we've seen over the course of the last half-century significant global decline in kelp forest densities around the world. And although global stressors are in part responsible for these changes, what we've seen primarily is that local variations and regional stressors are actually more responsible for these declines in kelp forest densities. These specifically include increased levels of marine pollution in the environment, as well as ambient temperature changes and the increasing prevalence of invasive species. In northern central California, for example, purple sea urchins have decimated local kelp beds to the extent to which now these kelp forests are struggling very hard to recover. At the same time, however, we've also seen increased pressure from unsustainable harvesting practices that has further led to the decline in kelp forest densities. Next slide. And this is because kelp is one of the most versatile resources that we have as well. Traditionally, kelp has been used in a variety of human food products, but more recent research suggests that kelp can actually support the reduction of methane emissions from ruminant animals when incorporated into their feedstock. Kelp also has the potential to support the development of biodegradable plastics, as well as sustainable fashion. And finally, as something that the U.S. Department of Energy's ARPA-E Mariner program is particularly interested in, kelp has the opportunity to become a sustainable source of biofuels, especially if it is produced at a large scale. Next slide, please. And that is why Ocean Rainforest, if I could get the next slide, please, that would be excellent, has worked for the last 10 years developing a sustainable method of cultivating seaweed in offshore environments. We've applied science, research, innovation, and expertise to iterate and refine all aspects of the seaweed value chain. And this allows us to begin to scale up our operations in a way that will be able to support growing global demand for this amazing source of biomass, while simultaneously ensuring that we are actually preserving and protecting many of the kelp forests that exist around the world. Next slide, please. But perhaps what's most interesting about our work thus far is that we've had the opportunity by our work in offshore cultivation, as well as in the United States and in the Faroe Islands, to really see how many of these technologies that are traditionally applied to kelp cultivation can then be translated into kelp restoration. And that's something that specifically our team in California has become increasingly interested in. And I'm happy to speak with anyone offline about some of our ideas associated with kelp forest restoration in the local environment. Next slide, please. And with that, I would like to thank you all for your time this morning. My contact information is on the slide, and I'll be happy to answer any questions. Thank you.
Thank you, Eliza. That's wonderful. And Shimrit will be next from ECOncrete.
Hi, everybody. Thank you for the time this morning. I want to talk about my perspective on habitat creation through harnessing heavy-duty infrastructure in the coastal and marine environment. It's kind of deviating on what we've heard from Tom, but taking it more to the direction of actual infrastructure works. Next slide, please. When we're looking at the ocean, it might seem infinite, but obviously with the way that we are utilizing the marine space, it's not. Next slide. What we're seeing is more and more usage of the coastal and marine environment, including the construction of various marine infrastructure, if it's renewable or non-renewable. Next slide, please. All of these structures have a huge footprint on the seabed, and we're seeing a lot more structures made of concrete, as Tom mentioned, which are not supporting healthy ecosystems and are actually mostly attracting nuisance species and invasive species because of the way they're designed and because of the material that are presenting. Next slide, please. So what we've come up with ECOncrete is a biomimetic solution that takes three components of concrete infrastructure and basically makes them support marine life in a much more efficient way. We're working on a concrete additive that is basically neutralizing the negative effects of concrete on marine life. And we are working on surface textures and biomimetic designs of our products in order to support a much richer and much diverse marine life on active heavy-duty infrastructure. Next slide, please. And this is really how we bring life to the concrete. And as you can see, there is a rich diversity of marine life here, which obviously provides a lot of different ecosystem services. Next slide. When we're looking at the ecosystem services, we're talking about adding different biological niches, getting much better ecosystem services, reducing the dominance of invasive species, and also potentially contributing to water quality. Next slide, please. The beauty is that the life that actually adheres to the concrete are providing the concrete with a bioprotection. So we're seeing less erosion and corrosion and a better concrete performance because of the rich life that develops on ECOncrete. Next slide, please. Those same organisms, like oysters and tube worms and coralline algae, are also creating an active carbon sink in a process of biocalcification. So we're seeing a real suite of advantages that are taking nature and helping it become even a better infrastructure because of that biomimetic approach. Next slide, please. I want to give you a couple of examples. This is our marine mat. As you can see, it has a lot of different features and different nooks and crevices for marine life to thrive on. Next slide. And the way that we're looking at it is to really replace the current standards of marine mattresses and create a habitat while we are protecting the infrastructure. It can be the foundations of oil and gas pipelines. It can be the protection of offshore wind turbines. And for this reason, these applications, although they are very much in tune with nature, they also have to be supportive of the infrastructure, and they have to undergo significant examination and physical testing. Next slide, please. We've also done some research on this with Van Oord around nature-inclusive design for offshore scour protection that's also supporting oyster communities. And in fact, ECOncrete was tested as opposed to several natural materials and was found very efficient in recruiting oysters. Next slide, please. Another example I want to give you is armor blocks. So really, this technology can be applied to any concrete infrastructure. With armor blocks, we can provide scar protection, and we can actually build breakwaters. Next slide, please. I just want to give you an idea of how it looks like before and after, or more to say, a gray installation that has regular concrete with no features is practically lifeless. Whereas at the same time, when we're using our technologies, we can get double the species richness and double the biodiversity and a much greater similarity to natural reef communities. Next slide, please. As I mentioned, when we are working with this, we have to be in full compliance with heavy-duty engineering requirements. So we have to undergo fume testing and concrete testing. And in this case of these breakwaters with our technologies, they're actually tested for a superstorm Sandy type scenario, like a 100-year storm event with sea level rise projections. So it's kind of a delicate balance between the needs for ecological uplift and the need for risk reduction. Next slide, please. In this case, I can also tell you that when we're integrating nature-based solutions and creating better habitat infrastructure, we can actually receive some permitting reductions, or basically facilitated permitting. And this was, for example, the case in that big project that I just mentioned, that's actually received recognition as on-site mitigation measures. So we're creating habitat through risk reduction measures. And I think that's the way to look forward. Next slide, please. And I'm very happy to say that we're seeing more of these pro-environment policies going into place, including a catalog for nature-inclusive designs that shows a suite of different solutions that can be implemented for coastal protection measures, which also create habitat value. Next and final slide. I really want to say that these types of win-win solutions, like you heard today from all three of us, are contributing to our capacity to provide sustainable development in our coastal environment. Thank you.
Thank you very much. Those are action-packed presentations with so much information. It's wonderful. I have a couple of questions, one for each of you, and then I know we're going to go and get some questions from the audience here. Eliza, could you talk a little bit about, you mentioned that you're working in California. Could you provide a little bit more detail on how you are engaging with California with the seaweed growth?
Absolutely, yes. So our work in California is something that's a bit of a recent development that stems in part from our work with the Department of Energy's ARPA E-Mariner program. So about 3 years ago, Ocean Rainforest got involved in a project that is looking at sustainable offshore seaweed cultivation strategies specific to the United States, and became increasingly interested by that project in the Santa Barbara Channel as a region that could support the development of these kind of large-scale, sustainable, durable systems. And so what we've done is recently, and the reason that we're now really starting our operations here, is that Ocean Rainforest became the prime contractor that is associated with a project called Macro Systems that is really looking to test this really interesting, highly scalable system as a demonstration project for the next 3 years in the Santa Barbara Channel. So our work in California is kind of twofold in that one part of our work is developing a small-scale hatchery facility, which will facilitate the growth of the gametophytes that will be used to seed this structure. And then the other component will be installing this offshore system about 4.5 nautical miles off the coast of Santa Barbara as a way to demonstrate that this is actually a potentially scalable and viable business opportunity.
And can you talk a bit about the business opportunity? Who gains from this?
So because it's a project that's funded by the Department of Energy, originally they were most interested in the opportunity to produce large amounts of seaweed for biofuels. But since the original call for proposals, they've since expanded their scope of focus to also include animal feed. So that's kind of where we're looking in terms of our work in California.
Great, thank you. Tom and Shimrit, you guys both mentioned offshore wind and both the foundations, and then it looks like you're showing cement mattresses for cables. I'm assuming that's what I was looking at. Given that in the Northeast we're going to see more than potentially 2,000 wind turbines off of our coast in the next 10 years, what is your recommendation for integrating some of your technologies into the siting to enhance habitat? Shimrit, why don't you go first?
Absolutely. I think that what needs to happen is that a part of the design of these offshore wind fields, we have to take into consideration the needs of the ecosystem to include research studies and knowledge that's already out there about what are the species that were utilizing the space, what are the fish species that have to use the space as nursing ground. And we have to integrate those features into the design of the scar protection measures or even the gravity-based measures of those turbines. And I'm happy to say that we're actually already starting to work on that, working with some of those offshore wind developers on these types of analyses. And actually we can come up with very targeted designs that are basically doing double. They're doing the scar protection and creating habitat.
You're doing that in the United States or in Europe?
Yeah. No, we actually started that. We were doing some work in Europe around the Netherlands, and we're now also doing the same process of studying and coming up with specific designs in the US in the state of New York.
Oh, great. Wonderful. Tom, do you have any thoughts on this question?
Obviously echoing what Shimrit said, but I think for the US, they've got a unique opportunity to learn from Europe's mistakes. So we've already put down concrete mattresses on a vast scale. 80,000 are down in the North Sea from the oil and gas industry. And you have the opportunity now to look at across the water and say, we're not going to do it that way. We're going to build with nature. We're going to lower decommissioning costs, but at the same time build back the marine environment. It's sort of a win-win. And I think for a long term we've been looking at capex as the main driver, whereas really if you look at the full life cycle of technology, the decommissioning costs, especially in offshore projects, can be just as expensive as the capex. So we need to look at the whole life cycle of the technology, not just the capital expenditure cost.
So what recommendations, if you were advising the state of Rhode Island or Massachusetts as far as policy, would you require, what would you, if you were king, not to say we have kings over here, but if you were king for a day, what would you require from the offshore wind industry?
I would probably put a ban on high CO2 and plastic riddled subsea protection assets going down, but that might be seen as a bit extreme. I think second to that, there should be a really hefty bond placed on them. So if they can't be recovered for any reason, then there's a big pot of money that can be used for restorative purposes or to recover them. I think at the moment companies are getting left off the hook by leaving these products down because they're seen too hard to remove, or they're in a state that they've broken down so much they're not safe to remove. So again, this comes back to if you can build something with nature in mind and it doesn't have to be recovered from the beginning, then you've got a win-win solution for the developer and for the environment.
Great, thank you very much.
If I can just make a small addition, actually in the US, you already have some regulations around mitigating for fill in the marine environment. So when you're actually putting stuff in the marine environment in the US, you have to mitigate for that. And in the state of New York and other states, you can do that through mitigation banking, where I can tell you that 1 acre of fill is equivalent to between $1 and $1.5 million. So you actually have the regulator paying for those types of intrusions to the marine environment, which is amazing. This regulation doesn't exist yet in Europe. But what I would suggest is, if I were queen for a day, would be to actually acknowledge nature-inclusive designs as a mitigation offset tool. We've already had some successes around that with a New York project that's coming up with breakwaters that had a massive footprint on the seabed, and because of the habitat value, the regulating entities have reduced the mitigation fees quite substantially. So if we can, let's say, give a discount on the mitigation, or even kind of expedite the permitting process for projects that are using nature-inclusive designs and are creating habitat, not only disturbing the marine environment, I think that could make a really good incentive for best available technologies and new technologies like ours out there.
Great, thank you. I do see a question here, but I wanted to ask Eliza another one about when you grow your seaweed. You mentioned that you needed pristine ocean. Do you, maybe I misunderstood you, but do you really need a pristine ocean, or could you harvest your seaweed or put your seaweed in waters that maybe need to be cleaned, and maybe waters that that could benefit from the harvesting or the growing of seaweed filtration?
Yeah, no, that's an excellent question. And one of the things that I think is a little bit confusing is that the waters of the North Atlantic are fairly pristine in nature. And so working in the Faroe Islands, we have this incredible benefit of already working in areas that are very, very clean. But seaweed actually doesn't require a pristine environment to be able to grow. And actually, if you have more nutrients in the water that are coming, for example, from anthropogenic sources of runoff, that actually will serve as fertilizer for the seaweed. So in that way, it will stimulate growth, which is helpful. So you don't actually need pristine areas, and there are some projects I know that are working in bioremediation of seaweed, or using seaweed, because it does have this capacity to naturally filter water. So that was unclear in the slides, but yes, we can work in anywhere from pristine quality waters of the North Atlantic to somewhere that's less pristine, like California.
Excellent. Okay, so here's a question from the audience, and I believe, Tom, it's directed at you, but Shimrit, if this is may be responsive, you could respond to this as well. Could you elaborate on how reef cubes help with anti-trawling? So go ahead. I don't understand anti-trawling. I know what trawling is of fishing, but I'm not sure what anti-trawling is.
Yeah, so in marine protected areas, especially that are close to destructive fishing practices, the sort of go-to methods are patrol vessels, satellites are sort of coming into it, and now drones. Both are very expensive and time-consuming, and some of them can be bribed and open to corruption. So there has been some success previously in the Mediterranean about putting down big concrete structures, because we can cast reef cubes from anywhere from 5 ton up to 12 ton, and we're looking at even bigger than that. And once you have a big structure like that on the seabed, it's there 24 hours a day, 7 days a week, in any weather, so at any time of day. So what you're finding is that the fishers or the fishing community who are in the area, one of the big things they don't want to do is lose their nets, snag their nets, lose their gear, because that's a big cost to them. So if you put these structures down and it risks them entangling their nets, then it's going to be a big deterrent. And there's been a few reports of that in the Med and in developing countries where they sink railway sleepers. That just doing that pushes fishermen out of the way. So we're also looking at acoustic arrays inside the reef cubes to detect a fishing vessel, and then scramble a drone to come to the area.
Shimrit, do you have a thought on that?
Well, I wish we didn't have to put more concrete in order to prevent from fishing with trawling, but obviously it's something that is providing a practical, relatively easy solution. So definitely, if we have to do that, it's best to use designed features and let's say nature-inclusive designs for those types of reef structures. And I still think that there is a need to have, every piece of concrete that we put in the marine environment, even if it's carbon neutral, it's still, we need to think about, do we really need to put that? And only if we've exhausted all of the other options, then yes, let's use better concretes. That's what we're for.
Okay. Eliza, just similar to conflicts with resource users, when I was looking at some of your images with all that seaweed, are some of the recreational boaters concerned about what is your relationship with recreational boating activities? Are they allowed to access your farms, one, and two, are they concerned that their propellers, for example, or they might get, it might cause havoc on their boats, for example.
Yeah. No, absolutely. And that's something that we have been really interested in managing both in the Faroe Islands, but increasingly in California as we start to go through the permit application project process to secure a site for the demonstration project in the Santa Barbara Channel, which is, of course, very popular both in terms of commercial fishing, but also for recreational fishing as well. And so how we've navigated it historically is that we haven't had many issues associated with competing space in the Faroe Islands for fishing modes. But what we have seen in California is that our team understands that there's already these existing industries, both for recreational as well as for commercial, and so has worked very actively with representatives from those industries in order to understand that in order to make sure that the placement of the demonstration project can be in an area that will have a minimal impact on their existing operations. So that's been specifically very important to the commercial fishing community in the local environment, and what we've found is that there are areas that are more or less ideal for us to run this demonstration project. And so in that way, what's it indicated, that indicates to us is that really siting and site selection processes are going to be the most important in terms of addressing that potential user conflict. And then in terms of recreational boats, we are not, the site will not be closed to the fishing communities, but considering that there will be a fair amount of gear in the water, including ropes and buoys and anchors, it would generally be advisable to stay outside of the site. And that said, though, there is opportunity to still fish around the site. And so in that way, especially for recreational fishers, by creating a seaweed farm in almost like creating a floating seaweed ecosystem, you still will have that value of creating habitats. And so then even outside of the farm itself, recreational fishermen would have the opportunity to still catch a number of species that might be using that kelp forest or that kelp cultivation system as an area to kind of hide out. So in that way, the area around the farm would actually be beneficial to a number of these recreational fishermen.
Okay. Is that the same, Shimrit, with your technology as far as serving as sort of an artificial reef and enhancing fishing, recreational fishing, for example?
Well, while my background as a PhD in marine biology was around designing artificial reefs, we did kind of focus around infrastructure and the function of infrastructure as an enhancement measure for habitat value. We did find certain cases, like the breakwater system that I represented, that we do an infrastructure that's actually providing multiple functions. It functions as a risk reduction component. It creates habitat for different organisms, so it uplifts the ecosystem, and it's also designed to be used for recreational purposes. For example, there's places outside and inside it can be used for diving or even kayaking, and that kind of links the ability of an infrastructure to serve as different tools for different stakeholders, basically. I saw another question here.
Yes.
I don't know if you want me to take it.
Okay.
So regarding
can you repeat the question? I'm not sure if people can see it. So I'm not sure.
Yeah. Do you have an example for oil and gas infrastructure working harmoniously with habitat creation? It seems counterintuitive. I agree. These are basically operations that are taking resources out of the marine environment, and I think that's why Tom and myself are trying to find ways to reduce their ecological footprint by at least helping and constructing some of their scar protection measures, if it's marine mattresses, if it's any kind of protection to the cables, that will actually double as a habitat. And I think I'm the last one to say that we should encourage these activities. If we can avoid using those marine environments for exhaustive reasons, I support that absolutely. And we don't want to be a greenwash or a blue wash, but if there's been a decision that these structures have to go, we can help the companies that are doing those activities to reduce some of their negative impacts.
Great. Do any of you collaborate with integrated multi-trophic aquaculture projects?
Yes,
Tom,
we do.
go ahead.
So we have a project called REFAS, which stands for Reef Enhancement for Aquaculture sites. So that's a scallop farm that's been built in the southwest coast of England. And what we're doing is we have built a subsea reef around the farm. It serves two primary benefits. One is fishing trawlers kept on going through the farm because although it was a closed area, they felt there was a right for them to fish there. So by putting our blocks there, it's deterred the damage to the kit. And secondly, it was a previously trawled area, so there would have been mudstone and sandstone reefs there, maybe 1 or 2 meters high, but they have been trawled to destruction. So this is replacing hard substrate that would have been there previously. So it's not altering a sandy habitat. But one of the main benefits is that we've seen is that the local fishing community have now seen the reef as an opportunity to fish sustainably. And although they're not trawling there, they are now putting down a sensible amount of static gear and passive gear, so crab pots, lobster pots, that type of thing. And now what's happened is the relationship between the aquaculture owners and the fishing community is greatly improved because they're looking out for one another and they're both benefiting from the site. What we're doing now is we're ensuring that the fish stock is sustainably fished and not depleted or overstretched. So that's now involved in a 3-year study where we're using eDNA, the catch data from the fishing community and ROV surveys to ensure that the species remains stable and that it isn't overfished.
Great. It sounds like all three of you are, I know you're all businesses, right? And however, you're also is creating, your product is creating partnerships between developers and conservationists, municipalities, federal government. Is that true? I mean, and is that intentional? Is that part of your mission? Maybe, I don't know.
Absolutely. I think that for all of us, each of us in our own fields, that is creating new technology, almost sometimes a new paradigm of looking into construction, for example, in the marine environment. We can't do it alone. I mean, companies that are relatively new, bringing innovation, have to collaborate. And for that to scale, we have to do even bigger partnerships that I think have been achieved until now. Working with port authorities, for example, now working with the Port of San Diego, they have a great incubator for blue technologies to actually assimilate and deploy innovation in the port. Same with Port of Rotterdam under Port Excel. So I see that there is also an eager side from those stakeholders to collaborate in order to scale these.
Eliza, you're nodding. Do you have a similar experience?
Yeah, absolutely. I think that's one of the interesting opportunities associated with working in kind of a pioneering industry, whether it's with seaweed cultivation or kind of sustainable construction in the ocean, in that it requires bringing together all variety of stakeholders and then making sure that we collectively understand how to do the work that we want to, that will ultimately have this larger positive impact, but in such a way that doesn't affect or negatively impact the existing work that's being done. So I know that's something that we've been really focused on specifically in California by engaging regulatory agencies as well as these local fishing groups, even local governments, to be able to understand how we can really maximize our community benefit, especially as we continue our work on this demonstration project. And more generally, I do think, I mean, the seaweed industry specifically is quite small, or is relatively small, and so there's huge value in terms of helping each other navigate these critical challenges that the industry as a whole is facing, in order to ensure that we can collectively support the development of this seaweed-based blue economy.
Great. So Tom, I'm going to direct this to you, and other panelists feel free to add in, but Tom, speaking of offshore wind and oil and gas, are these industries proactive about habitat preservation?
I would say, on the whole, yes. But if I'm being completely honest, there's a cost thing in here. So a lot of them say, you know, we're an offshore wind company, not a marine conservation company primarily. And, you know, one problem we're coming up against is, you know, these projects cost billions of euros to make, which sounds like they should have the money for something like this. But the reality is all that money is costed way before, you know, a single turbine goes into the water. So, you know, you have to sort of go in at the design stage to have a chance of being used in an offshore construction project. coming in halfway through a construction period is almost seen as, no chance. So they are open ears, but you need to get in early. And again, they're extremely risk adverse. These turbines cost £12 million each, and they don't want technology going around that hasn't been proven that could damage any of their assets. I think the intention is there. And I think with what we're starting to see now is with regulation shifting them in that direction, especially in Holland and Belgium. And as Shimrit said, there's similar projects going around and regulations in the States. What we should actually see is it now become mandatory. And the minute regulation becomes mandatory, I'm sure they'll be able to find the money to fund these type of projects.
Well, and I would also imagine that, at least in the United States, there's a huge public process, and there's, concerns from conservationists as well as, municipalities and whatnot. And if these companies could demonstrate potentially habitat enhancement and benefits for recreation or commercial fishing, it would minimize that tension. Do you see that, Shimrit?
Yeah,
for sure. I mean, sorry, Shimrit.
Go ahead, Shimrit. Sorry.
For example, we're seeing now in the U.S. that the strong environmental groups, even the fishing groups that are operating in that space, have quite a heavy weigh-in with the decision-making process, and the state is very much in conversation with those entities, including the developers. So as long as, our challenge, I think, as innovators is to spread the word, basically, so that they know that we are bringing technologies that can help make that win-win solution, and they can actually advocate kind of bottom up. While in parallel, we do need to work top down from the regulating agencies to have them request those nature inclusive designs into the fields, and not just leave it to the developers themselves.
Great. And one other question. So I represent the University of Rhode Island, and I just wanted to know, and Tom, I know you have an answer to this question as far as how do you engage universities, whether it be students or their engineers or oceanographers? I mean, sometimes universities are also brought in because we're considered objective and not, we don't have for lack of a better expression, a dog in the fight, and therefore our monitoring could add value. Are you guys, any three of you, connected to universities? If so, how?
Yeah, so we have close affiliations with the University of Plymouth and the University of Exeter. They've helped us in the early stages verifying our technology, raising the technology readiness level. And like you said, they're a third-party verifier to say, we've run some tests, these are the results, and it looks good for an SME to have that, especially when breaking into offshore energy industries.
Yeah, I think the same is true for ocean rainforest, especially working in the United States under the context of this ARPA-E Mariner program, which has 5 categories that were all are intended to address different aspects of offshore seaweed production. And 2 of those category teams are based out of the University of California, Irvine. We also have UCSB. And so we, as an entity in California, have worked very, very actively with them to understand kind of what the local environment is here, but also, especially going forward, we'll continue to engage them to understand how our research actually in the field can support their modeling efforts or their kind of more discovery-based research as well. So universities, especially in the United States, but I know around or both as well as in the Faroe Islands, have been really critical to our ability to move forward as a company.
Shimrit, do you have another thought on that? I wanted to add anything to that? Or
Absolutely. I think it's inherent to work with academia. We are also collaborating both with universities and even with high schools that are operating in the space. I think it's a part of both validation and education and outreach. So we've actually had high school kids from New York do a science project and win a science fair competition with our collaborations. And that's something that I think has to be a part of that in order for the next generation to work with nature inclusive designs.
Great, thank you. So they took away the timer, but I think does anyone see the timer? Okay, so I just want to just end this by, is there anything, Eliza, that you would like to add to this conversation? One last point.
I mean, yeah, mostly the collaboration is super important, regardless of whether or not you're associated with the university. And I know that what's interesting about Ocean Rainforest work so far is that we are not kind of a traditional conservation organization, and because we are mostly working in seaweed cultivation. And yet I'm really grateful for the opportunity to be here today, because I do think it's really important of how we can see how our experience, especially working in cultivation, can be translated to different conservation techniques and used to really create those habitats and protect these existing ecosystems, which you both are very actively involved in. So I'm very grateful to be here, and I'm super excited to continue to see you work.
Great. Any other just brief last minute, or should I close the session? You guys good? All right. Well, thank you all for serving on this panel. I learned so much. It's wonderful. And thank you all for those who have listening to us. Again, I have no idea who you are, but thank you very much, and enjoy the rest of the event.
Thank you, everybody.
Well, hello, and thank you for joining us for BlueTech Week 2020's panel on unexploded ordnance and sunken vessels. I'm your moderator, Sean Newsom with Shorebreak Tech here in San Diego, a proud member of TMA BlueTech. This is a topic that's been really important professionally to me. I've experienced throughout my career, and I'm really humbled to have been asked to be part of this presentation. Unexploded ordnance is an international issue. It's thought of more in places like the Baltic Sea as a result of the wars, but it's also something that's right here in San Diego as well, just off our shores. When people think of unexploded ordnance, they think of landmines typically because it's above the waterline within the radar. The Red Cross, International Red Cross, said that UXO deprives people of water. I'm sorry, I have audio over. Okay, I'm sorry. I hear another presentation. Anyways, the International Red Cross states it deprives people of water, firewood, farmland, healthcare, and education as it impedes relief work. We could argue similar in the underwater community. The underwater UXO deprives people of clean water, marine resources, farmland, safe installation of sustainable wind and wave energy, as well as provides potential access of dangerous materials to bad actors. I'm going to give a brief introduction to each one of our panel members ahead of their presentation. And then after all four presentations, we'll open it up to questions. I'd encourage you to ask a question. You can put it in the chat box. If someone likes that question, vote on it. So if we're running short on time, more popular questions will be asked. In lieu of that, I have some individual questions for each member of the panel. So let's start now with Steve Link. Steve is the director of Seabed Systems and Offshore Energy for ThayerMahan, a marine robotics and services company based out of Connecticut. Prior to joining the organization, we served as a naval explosive ordnance disposal technician and included roles in mine countermeasure platoon commander and team leader for clearance operations in Northern Europe. Go ahead, Steve.
Hey, Sean, thanks a lot and really appreciate the opportunity to be here today. Great introduction. The UXO problem we often think of being strictly an overseas issue, but as we can see with especially offshore wind development on the East Coast here, it's becoming more of a prevalent problem. So I'm going to talk about one of our potential solutions, and it's only a small piece of the entire UXO issue, but an important piece, and that involves localizing and verifying the actual presence of explosive ordnance in the region. So Sean mentioned I work for ThayerMahan. Our CEO spoke on Tuesday, or COO earlier today. So if you've already heard the spiel on the company, I'll go through that pretty quick here. Connecticut-based defense firm right here out of Groton, and focused on small distributable assets, really platform agnostic, to kind of move away from this paradigm of large capital-intensive, manpower-intensive assets to help provide a better sense of the maritime domain. And what I'm going to focus on is this towed asset right here. You can see the yellow torpedo-looking thing, our Sea Scout system. It's an actively stabilized towed vehicle with synthetic aperture sonar payload. And why that's really important to us is we're able to achieve range-independent resolution with the SAS, because the angular resolution is going to be a function of the frequency and the real aperture. You can either have a very high frequency sonar, but in which case your data is going to degrade over distances, or you can have a very long real aperture, but in which case there's operational issues, manufacturing issues, deployment issues, and whatnot. So if you can synthetically generate the aperture over the path of travel of the vehicle, you can start to get a better sense of the entire op area without having to have multiple passes or multiple looks to achieve the desired resolution that you require. And if we can go to the next slide, please. And you can see here's an example of a sunken vessel that we imaged with the Sea Scout system. This was during an underwater cultural heritage site cruise with NOAA back in 2019. And as I mentioned previously with SAS, the nice thing is you can start to get this macro level view of the area, but then start to pick out finite details. Here you can see the debris field, the propeller shaft. And why this is important is because the UXO problem, many times in many countries, it's not really an issue of somebody dropping the ordnance and it failed to detonate. but rather it can be on a vessel that was transporting it, most likely in an unarmed condition, but still at the same point it represents a hazard. So being able to image the entire op area in one pass, for example, but still having the opportunity to pick out small items of interest is increasingly important. And here's an example of how we could do that with our system. You go to the next slide, please. And here's another sunken vessel. In this case, this is a U.S. submarine, USS Bass. This was not a wartime casualty. Rather, the submarine itself was commissioned in the 20s, decommissioned in the 30s, and then brought back to life for service during World War II. And then it was used as an actual target for an experimental acoustic homing torpedo at the time. If you go to the next slide, you can see the test was quite successful, where the front end of the submarine has been blown off here. But what we can do is we can look at the individual portholes. You can look at the compressed air tanks to the top of the image and to the bottom of the image. And that further validates the thesis that we want to have a holistic view of the area before we send down an ROV, before we send down a diver to interrogate potential explosive hazards. And again, with the towed system, what we can do is we can cover approximately 3 square kilometers per hour. So we can cover a large area without having to get too close to the ordnance itself, which from a time on target issue is important in non-permissive environments. Obviously for permissive, it translates to a operational expense. So the faster we can get out there, the less time we have on site, the better it is for us and better for the customer. Go to the next slide, please. Finally, you can say, okay, yeah, well, great. You showed me wrecks that are hundreds of feet long, and that's fine. You can pretty much pick that up with any sensor. A hole mounted multi-beam is going to pick up these objects. But what's unique about the SAS is you can also start to identify smaller objects within the area, as I keep mentioning. And here's a particularly interesting image. So now we'll collect individual snapshots or tiles. We're not going to have this consistent waterfall data that some folks are used to. But what I have here is actually a repair job on a LNG line. And it was either for repair or they had a poor lay and they had to fix it. But what's highlighted in this image is you can see an actual lobster pot with a piece of line in the area. And so when you do have this, I wouldn't say cluttered bottom type, but disparate bottom type, where it might be very difficult to identify individual hazards, when you utilize a sensor as advanced as the synthetic aperture sonar, in this case, the interferometric synthetic aperture sonar, you can start to get very fine 2D detail, but also bring in the 3-dimensional detail. And we'll do that, like I mentioned, with the interferometry or with the conventional multi-beam that's really used as an altimeter. So when you start looking at these 2D images and you co-register that with the 3-dimensional data, you can start to build an even more complete view of the operational area. And so what we've been doing with this system is we've been primarily looking at critical infrastructure. You can think of pipelines, you can think of cables, but also migrating it to the UXO problem that is budding out here in the Northeast. So the end goal is to apply the sensor to be able to localize ordnance or hazards in the area and then turn over the information to folks with maybe a sub-bottom imaging capability, folks with an ROV or dive capability to render safe or remove the ordnance. You can go to the next slide. And here's just my contact information. If anybody would like to discuss more on the topic, please feel free to shoot me an email at any time. Sean mentioned background as an EOD, like many of the folks you'll hear from today, which is very unsurprising. So the topic is very near and dear to my heart, care much about it, and always willing to talk. So thank you for your time and standing by for any questions.
That was a great presentation, Steve. I appreciate that. Our next panelist is Moya Cahill, co-founder and CEO of Pangeo Subsea Technology Service Provider. They do 3D sub-bottom acoustic imaging technologies and are headquartered in St. John's, Newfoundland and Labrador. They use synthetic aperture sonar and provide enhanced sub-bottom data, imaging buried geohazard and mitigating risk for offshore installations for oil and gas, offshore renewable energy, and defense sectors. Moya is a professional engineer holding a Bachelor of Engineering degree in Naval Architecture and Marine Engineering from Memorial University in Newfoundland, with over 30 years experience in oil and gas sector and offshore renewable energy sectors. Take it away, Moya.
Thank you very much, sir. I've got a bit of an echo here. So if we can go to the slide, and today I want to talk a little bit about our technology, particularly our sub-bottom imaging technology. And before I go there, I'll talk a little bit about the company and show you some case studies on where we are with regards to unexploded ordnances. So the next slide, please. Yeah, so like you mentioned, we're based in Canada, just on land in the middle of the North Atlantic. But we've certainly, we grew out of the oil and gas sector. We have an office in Aberdeen, in Scotland, and because of now of our growth within the offshore renewable energy sector, we've now are expanding into the U.S. to address the burgeoning offshore wind farms in just off of the Northeast. We've got a number of strong client base. Because our technology is very unique, we tend to be so we focus primarily on the operators. So let me first tell you a little bit about our technology. So our next slide, please. Yeah, so today I want to talk about our sub-bottom imager. And our sub-bottom imager is a tool that actually, it flies about 3.5 meters above the seabed. And we're actually collecting acoustic data. We're collecting 3D volumetric acoustic data real time. So on board the vessel, we can visualize that data real time in a number of different aspects. So there on the far left, you're actually seeing the volume of data that we're collecting. So this volume of data is actually 5 meters wide, and it can penetrate the subsea bed anywhere from 8 meters. So in some ways, it's similar to an MRI, where we can actually slice down into the data set, and it's like an MRI. Organs will actually image the anomalies in the subsea bed. We're measuring acoustic intensities, so the red reflections are the harder surfaces that we're imaging, and the blues are the more transparent, like the muds and the softer clays. On the right-hand side, actually, is our 2D views of the data set. So we can see a top-down view, a cross-sectional view here, as well as a longitudinal view. So we're actually tracking, if it's a cable we're looking at, or a pre-route survey, for example, we can actually track the anomalies in our subsea bed real time. So next slide, please. So our real focus and what really has been driving the growth of the organization over the past couple of years are UXOs. And here you'll see, and that UXO application is being driven by the offshore wind farms. These offshore wind farms, certainly it was Europe that pioneered these offshore wind farms commercially, and certainly between the UK as well as continental Europe, during the war, over 50 million bombs were dropped. And now that they're installing these offshore wind installations in that region, there's certainly a lot of significant risk for these ordnances, for these unexploded ordnances. And so we've been brought in by the industry to actually image these anomalies. Of course, because we're using acoustics, we can image either ferrous or non-ferrous, because we're actually looking at the shape, the acoustic boundary that is wrapped around the anomaly. So metal ferrous UXOs, traditionally have been found using magnetic magnetometers, but towards the latter part of the war, the Germans were using actually. And this one particular mine that I have up, the LMB being Lufte, being air, they were parachute mines, and they were dropped from air and landed on the seabed. Very, very challenging to detect because they were made of aluminum. But like I said, because we're able to look at the volume set, we can actually image these non-ferrous mines. So there you're seeing on top the typical. These are very large mines. They're some 2.2 to 2.5 meters long by 0.6 meters diameter. And keeping in mind what we're doing, we're imaging what's in the subsea bed. So if we can take a next shot, please. So here is a data set. This is actually how we're interrogating that data set. So if you click this should be a video. I'm hoping it's a video. Oh, it was a video. And maybe it's not available. Oh, there you go. Yes. So here you're seeing us interrogating that volume. So we're actually every 5 centimeters in that data and look at what's in it. So there, like once again, this is a top-down view, and we're looking for we're looking for a discrete anomaly in that data set. So there you're seeing the reflections on the side would be typical, indicative of different layers of stratigraphy, harder layers. But there on the bottom, there on a very stiff clay layer, is actually that discrete anomaly. And this would be indicative actually of a Club S missile. This was a mine that we found in just off of India, and it's about 2.6 meters long and about 0.0 meters in diameter. The watch is at first reflection up there is the, and once again mentioned that the mine is actually sitting on a stiffer clay layer. So next slide, please. Indicative of what we would show the client from a 2D perspective. There you're seeing the acoustic data set, that vertical reflection is the sea floor and going down stiff clear. This was a very challenging mine to find because actually it was buried some 6 meters in the subsea bed. And once we found it, as you can see, there's the Club S there on the top hit corner. Next slide. This would be a typical type of mine. This was a mine that we found just off of Holland. There you're seeing, rather than actually seeing the shell of the unit, the shell was very transparent because it was covered in a lot of marine growth, and we were actually seeing the components of that LMB mine. So we were seeing the charge, which was a heavy reflection. The center was the battery, and the very top on the right hand side was actually the parachute. Next slide. So I always like souvenirs home wherever I go. We particularly what things we find in the subsea bed, but unfortunately in this case the Dutch Navy got there before I did, and if you could just click that, you can see that they took over this before I could have a chance and detonated it. So if you click on that, you should see detonation of that mine, or not. There you go. So, ladies and gentlemen, that's our story, and certainly looking forward to responding to any of your questions here this afternoon.
Well, thank you very much for that, Moya. The non-ferrous detection is of particular interest. Find that quite fascinating. I hope we have some further questions on that. Our next panelist is Jeff McCauley, who retired after 30 years in the U.S. Navy just 6 months ago. Hoo-yah, Jeff. His extensive experience in the Navy included serving as a Commodore for Task Force 5-6, responsible for explosive ordnance disposal, naval coastal warfare, the Seabees, Expeditionary Forces, logistics support, and the riverine forces for the U.S. Navy 5th Fleet based in Bahrain. Jeff is now the Senior UXO and Munitions Response Technologist for Jacobs, an engineering consulting firm with 52,000 employees worldwide and $13 billion in annual revenue. His current focus is on developing UXO remediation plans for Vieques, Puerto Rico. Take it away, Jeff.
Sean, thank you very much, and to all the attendees, organizers, and my colleagues here, good morning or good afternoon, wherever you are. My name is Jeff McCauley, and my focus of effort in Jacobs is, as Sean pointed out, is really in the Navy CLEAN program. CLEAN, an acronym, of course, for the Comprehensive Long-Term Environmental Action Navy. And the part I want to delve into today with you all is a portion of the Navy CLEAN project we're working on at Jacobs down in Vieques. But first, I want to talk a little bit about Vieques itself. I think this may be the first time that Jacobs has been participating, and we're excited to do so. As Sean mentioned, Jacobs is more than 52,000 people strong and partnered with government, cities, and businesses in more than 50 nations, invested in a scope of projects that are across water, transportation, infrastructure, environment, advanced technologies, nuclear, and industry. And this bulk of work that Jacobs is involved in is really aligned to two primary lines of business, critical mission solutions and people and places solutions. All of that, of course, is with a common vision and goal, and that is a more connected and sustainable world, meaning a relentless pursuit of ideas and solutions that challenge today and reinvent tomorrow. So a little bit about, if you go to the next slide, Sean, please. Thank you. A little bit about the sustainability and what that means at Jacobs. Of course, that's ensuring long-term business resilience and success, but also positively contributing toward economy, society, and the environment. Ensuring the prosperity and environmental protection without compromising the ability of our future generations to grow as well and to meet their needs. And all these are rolled into what we call at Jacobs Plan Beyond. Plan Beyond is our sustainability strategy. It's constructed on a 3-pillar foundation of people, which goes into health and well-being of individuals, as well as inclusion and diversity. Places, which is optimizing our own footprint and also supporting thriving communities. And then partnerships, and partnering for growth and impact, and then also leading through innovation. And there's a nexus here that I think ought to be called out, and that's that Jacobs understands that as we pursue reinventing tomorrow, that is a collaborative effort. And it means we have to work with our partners, with our clients, industry, and communities. And that's why Jacobs is aligned with the UN 2030 Agenda for Sustainable Development. CH2M Hill, a wholly owned subsidiary of Jacobs, aligned with that also in 2016. And if you see on the TMA BlueTech site there's 5 of the 17 agenda items in common between Jacobs and TMA BlueTech. And it's interesting. Clean water and sanitation is one, affordable and clean energy, sustainable cities and communities, climate action, and then life below water. So, and there's consequences to not pursuing these goals. But then back to our architecture, within people and places solutions, business line, there's 5 different markets and 9 business units, all within people and places solutions. One of these is the Federal and Environmental Solutions, FNES, and specifically I want to talk about the Vieques Restoration Program. So I think we're on that correct slide right there. A bit about Vieques, if you didn't know. It's about, Vieques is an island, part of the Commonwealth of Puerto Rico. It's about 8 miles to the east of the main island. Puerto Rico is about roughly 20 miles in length, roughly 3 to 5 miles in width, kind of runs east to west, and a home to a population of about 10,000. Now, from 1945 up until 2003, the Navy and some of our allied forces tested weapons, including bombs, submunitions, grenades, projectiles, rockets, and you name it, and other military training activities out on the eastern portion of Vieques. There was about 15,000 acres in the Vieques Naval Training Range, and then another 12,000 acres underwater impacted by those operations before the Navy left in 2003. Much of the island at that point was then, when the Navy did leave, was designated a wildlife refuge, and it was also placed on the U.S. National Priorities List. This made Vieques eligible for assistance under the U.S. Superfund program with cleanup and remediation. So for Jacobs, our scope includes over 70 sites. 19 of those are munitions response sites, performing facilities planning and management and quality assurance for munitions clearance. And the highlight there is the picture in the slide is not of folks holding dispensed munitions or submunitions. Those are actually taking a look at some of the sea turtles that reside down there, because in cleaning up all these munitions, ashore and underwater, it's critical that we balance our solutions with preserving and sustaining the environment. So our services down there include developing SOPs, standard operating procedures for munitions removal, characterizing the impact of more than 50 years of military training on the environment, executing biological assessments to protect endangered species, assessing human health and ecological risks and explosive hazards, and again, keeping all this in balance. We have an extensive community outreach and community involvement program. We develop and maintain web-based munitions GIS systems to monitor progress of munitions removal. And to date, over 100,000 potentially live munitions have been removed. And it's important to note, at Jacobs, we're not doing this by ourselves. We work side by side with partners, including other UXO and MR companies, continuously, and that is in order to deliver the right solution to our client, Naval Facilities Command, and the people of Puerto Rico that makes sense from an environmental perspective. A lot of this involves diving. We've got teams of engineering, scientific, and munitions response divers, all within Jacobs, a collaborative group, mutually supportive in doing buoy inspections, investigations, site characterizations, and as we said, QA and QC of our munitions response program as well. Along those lines, we leverage new and emerging technologies that you just heard Steve and Moya talk about a bit as well, to provide safe access for munitions removal, and this includes terrestrial, underwater, and aerial systems, all used kind of in concert in order to more safely identify, remove, and then monitor our munitions detonations in our process. So NAVFAC considers, or Naval Facilities Command considers this a model for us to follow in risk management and establishing programs for munitions cleanup across the Department of Defense. Go to the next slide. So some of these remote technologies you see here, and not unfamiliar probably to anyone in this forum. Some of them you've heard discussed by presenters already, and I'm not going to delve too much into that. But there's a lot of reasons for Jacobs MR program to pursue new and emerging technologies, and that includes sensors, ROVs, and unmanned and or remote systems. Safety for people and safety of the environment, justification for some of the high risk procedures that we do, minimizing explosive hazards to our workers to the extent possible. And of course, a lot of this comes down to simply, this is more efficient and also more effective at getting the job done. Another benefit of this, I think, is a quality product with a tangible deliverable to our client. We're able to use these types of systems to have video, photos, and graphics that allow clients, regulators, and the public to see places and the features that otherwise they wouldn't be able to see. Next slide, please. So some of the takeaways from this is it's not easy. Every situation is a little bit different, a little bit unique. VIECUS in itself is unique. There are, of course, governmental challenges to be addressed, geographic challenges to be addressed, cultural, and it's a complex and multivariable environment down there involving underwater and terrestrial munitions response projects, right alongside land and water environments spanning geographic and interagency gaps. So balancing the work that we need to achieve restoration and then simultaneously preserving the environment to support a thriving community and ecological sustainment, and satisfying our client demands that we work with multiple partners across industry and include some of the teammates and the ones you've already met on this panel and earlier this week. So this is has been and will continue to be a long-term effort. And again, this is a model for what we're pursuing at Jacobs in addressing some of these problems that are common to all of us and also having a sustainable environment now and for in the future. So thanks again for hosting this panel, Sean, and for all of us. Jacobs is excited to be part of this discussion.
Fantastic presentation, Jeff. Thank you so much. As you know, I have done a little work with VIECUS and supplying unmanned systems as well. So it's an area that I just learned about in the last year and is of great interest and concern. So our next panelist is Kurt Nelson. Him and his partner, Anthony Rogers, established Orca Maritime here in San Diego in 2006. They're both retired Navy explosive ordnance disposal experts with extensive experience in underwater operations, including mine warfare, diving, and sonar mapping. Their use of AUVs and other sensor systems in real-world missions while in the Navy has provided a strong operational foundation at Orca Maritime. Kurt, we look forward to your presentation.
Thanks, Sean. Great intro. You did away with having to give background on the company, so I appreciate that. But I'm going to go through these slides pretty quick as we're running a little low on time. But we are an underwater services company that specializes in unmanned systems. Over the years, UXO cleanup on land has been increasing due to the scope of urban development and the expansion of the industrial land use that goes on in the country and around the world. But UXO underwater has been mostly just ignored. It's kind of an out of sight, out of mind situation. And there are literally millions of tons of ordnance worldwide from military conflicts, bombing, and weapons test ranges, coastal ocean dump sites. They all contribute to the problem. So over the past few years, there's been this push in offshore development, wind farm being a prime example. And so it's been brought to light that we need to mitigate or migrate this UXO remediation effort to the underwater environment. So we saw that going in, with our background on the Navy, we saw that going in that there need to be an efficient and effective and economical way to detect and map underwater UXO fields. And it's fast becoming a desired alternative to the traditional towed vessels with towed sensors with the big vessels or big and small. So next slide. So I'm going to talk about a case study here real quick. We found a dump site here off the Southern California coast. And the objective of this case study that we did was to be able to demonstrate the effectiveness of an AUV in detecting and mapping unexploded ordnance on the ocean floor and using that data that's collected to assist in remediation efforts. Next slide. So we use an IVER 3, and this is a picture here that you see of an IVER that's got in the technical details there that you can read yourself. But the IVER also has a towed magnetometer on it. And what's nice about this is it collects side scan, bathymetric data, and magnetic data, all georeferenced together all at one time. So it's one mission and it's collecting the different data sets at the same time. So it makes it a lot easier when you're doing a mapping effort. Next slide. So the first thing we did here off the coast was do a high pass. And the high pass is done to identify any navigational hazards that may be in play here when you do a low altitude follow-on survey with the AUV. You don't want to get your AUV hung up in ghost traps or lines that are down there or sunken vessels, rocks, whatever may be down there. So next slide. During the high pass, you can also take bathymetry data. So you have an opportunity to collect the bathymetric snapshot of the area that you're surveying to be able to lay side scan later on when you're doing mosaics to get a three-dimensional picture of the ocean floor and its objects. Next slide. So on the high pass, there was debris identified. In this case, next slide. It was a lobster pot. It was a ghost pot that had lines running to the surface, which is, you know, the ocean is a big place, but you know, when you're running sensors, whether it's towed or unmanned, they have a way of just finding those lines that are in the water. So we want to identify those lines right away and plan missions around them. Next slide. So using the data acquired in the high pass, we plan the low altitude mission and we plan these tracks to avoid this. And as you see with the little red circle there, that's where the high pass identified the lobster traps. So all the missions were planned avoiding any of these obstacles and anywhere that the AUV could get hung up. Next slide. So the next mission we ran was a high resolution mission. It was low altitude. It runs about 4 meters off the bottom. There's 10 tracks in this mission here. Took about an hour and 40, or I'm sorry, yeah, about an hour and 53 minutes. You can see. Next slide. And it identified the projectile field, or in this case, they are projectiles, but the ordnance field pretty easily. You can see the scouring in, and we do these so we can look at how many pieces of ordnance are down there and how extensive the field is and map the boundaries of the field. Next slide. There's also ordnance that can be seen in a semi-complex bottom. A semi-complex bottom is one that is not just sand or silt that you see in the last slide, but in this one you can see there are rocks and detractors that take away from the sonar being able to really identify. But you can identify ordnance objects, but you can see that there are still objects visible in that sonar data. Next slide. And here on the high resolution, you can actually see that these are projectiles. We counted over 250 of them, and they're easily identified through the high resolution data. Next slide. So in this field, there's also a complex bottom that we ran into where the ordnance was moving into a rocky bottom. It was very difficult to identify the ordnance items there, so we have to move into using a magnetometer to identify if, in fact, there are ordnance items in that complex bottom. You can go to the next slide. So this was a magnetometer mission, and you can see there are anomalies that kind of have that backwards J going up to the north, which identify that yes, there were anomalies there. So we, on the magnetometer data, next slide, you'll see that the when you overlay the side scan, you can see the field that's in the non-complex bottom moving up into the complex bottom. There's definitely something there. So how do we identify if there are ordnance items and what kind they are in the complex bottom? Next slide. So that's where the magnetometer comes in, and it's a total field magnetometer that we use, and it identifies not only the ambient magnetic field, but all these anomalies that are in there, and we filter those out. The next slide. Identifying the magnetic hotspots. So we can in fact see that there are ordnance items in that complex bottom. And so that allows us to identify a position and investigate with a remotely operated vehicle. Next slide. And sure enough, as we went down there, there is a projectile that's laying on the bottom in this rocky environment, this complex bottom. So that helps us to identify all the ordnance items, or as many as we can, that are in a bottom that would normally not be able to, we would not be able to visualize using side scan because of the clutter on the bottom. Next slide. So the combination of using an AUV and with an interferometric sonar, we get side scan data, we get bathymetric data, and we also, towing a magnetometer, we get magnetometer data that can effectively map the boundaries and the number of unexploded ordnance items that are on the bottom. It's a very efficient and effective way to collect data. It is, like I said, high resolution. And the other thing about AUVs that's really nice is it's a repeatable capability. So if you're working on mapping a remediation site before a cleanup effort starts, you can you map the site, you make a nice mosaic, a nice GIS is what we do with it, using our Esri ArcGIS. We make a nice underwater GIS of the site, and as cleanup efforts go on, you can repeat your surveys. Excuse me. You can repeat your surveys on the same tracks that you did the first one. So all your target aspects are the same, and you can see how much has been cleaned up, how much is still down there for your ultimate customer, saying, "Yep, this is good to go. It's all cleaned up," or it's not cleaned up. We still have some to go. So it allows the remediation team to monitor and manage their underwater site. Next slide. So that was pretty down and dirty, quick, but it definitely proved the efficiencies and the effectiveness of AUVs and using the technology to map underwater UXO sites. So back to you, Sean. Thanks.
Wow, fantastic presentation as usual, Kurt. We only have a couple minutes left. I'm going to go ahead and throw out a question. I'll ask Moya, and then I encourage all of you to respond if we have time. But there's a lot of concern these days with using acoustic equipment in the ocean affecting marine mammals and other sea life. And I'm wondering, how does your technology play into this, and as well as the other team members here or panelists that have time?
Yes, thank you. We've shown that our technology is actually mammal friendly because we're so low in this, so low in the water column. We're only about 3.5 meters above the seafloor. The majority of the acoustics actually is being absorbed in the subsea bed. So we've had instances actually where we've actually picking up seals swimming around our data acquisition source. But as a result of sound analysis, our data is we're using a range from anywhere from 3 to 15 kilohertz, so relatively low frequencies because we're actually penetrating the subsea bed.
Step in on that or respond? No?
Sure.
Please. Go ahead.
So I was going to say, high enough center frequency in the SAS, for example, where it's beyond harassment ranges, and then things like the USBL and DVL are not importing enough into the medium to really require PSOs, for example. So you get waivers for permits. So bottom line is, it's good to go.
Excellent. I appreciate that. Well, we went really close to time, so please look up our panelists and follow up with them with any applications. This has been the UXO and Sunken Vessels panel. Thank you so much, everybody, for participating.
Thank you.
Excellent. Thank you. Greetings and welcome to the Oil and Water session of the BlueTech Week. Hello, everybody. I'm Ellen Ramirez. I'm the moderator for this segment. I'm a supervisory scientist at NOAA. And first, I'll begin with my slides and an introduction of the panelists. Slides, please. Next slide. Before I begin my presentation, next slide, please. I'd like to introduce the distinguished panelists. Today, online, we have Flavio Andrade. He's a naval architect and a marine engineer by education. He's the president of Ocean Pact since 2007. He'll be speaking on a case study for oil spill prevention. We also have Chris Chase. He's the development manager for Interocean Systems. He holds an MBA by education. And in his work, he's helped develop an oil spill detection system. We have Jim Mullen. He's a managing partner with Earthwide Sorbents. He's a business executive with experience in recycling materials to be used for cleaning up oil spills. To the panelists, I'm honored to be sharing the mic with you today and to facilitate this dialogue. Next slide. I co-supervise the NOAA Satellite Analysis Branch. It's based in the Washington, D.C. metro area. And we produce rapid response, value-added products needed to support disaster management authorities and civil protection agencies. We have an oil spill monitoring desk. It commenced in 2011, and it's supported 24/7. We have an analyst that's on duty that inspects freely available multispectral imagery and synthetic aperture radar to monitor for non-natural oil releases in U.S. waters. We report findings to government and state agencies, but we also make these reports publicly accessible to industry, private sector, and the general public. Next slide. Our official product is the Marine Pollution Surveillance Report. It's a mix of text and graphical information where, upon the detection of a potential non-natural oil release, we highlight the possible oil anomaly, and we use a remarks section to elaborate on all of the supporting characteristics that lead to the decision that it's a non-natural oil discharge. And we also elaborate on reasons that detract from the confidence, including that the substance might be a false positive. And we do this on a routine basis using openly available satellite data. Next slide, please. To elaborate on the process, in visible imagery, we have an analyst who interrogates the satellite data. They will monitor for visual characteristics that support the anomaly being oil, including its color characteristics, its definition, its contrast against the ocean, and its structure. We also generate band wavelength combinations to distinguish from an oil signature, a petrogenic signature, from a vegetation or a biogenic signature. And the way that we do that is illustrated in the bottom two images. On the left, we have a dark anomaly in the center of the scene that appears to be suspicious and non-natural in the marine environment. And on the right, we've generated a composite that is sensitive to the near IR portion of the spectrum, where chlorophyll and vegetation preferentially emit. And as that color has turned red, it's likely that that feature is attributed to chlorophyll and not petroleum. Our sources of visible data that we use include Landsat from USGS, VIIRS from NOAA NASA, Sentinel-2 from the European Space Agency, and Modus Terran Aqua from NASA. Next slide, please. So here's a case study. It's a practical example of the service that we provide, and this case is from a wellhead blowout off the coast of Louisiana in December of 2018. So the analyst on shift, they inspected high-resolution multispectral data and delineated the extent of the oil plume on the surface. And we were able to deliver this information to the responders that were on site, and any of the officials needed to support the recovery, the mitigation, and the natural resource damage assessment. Next slide, please. Here's a zoomed in view of the raw data itself before that report was generated. And what I want to highlight in this slide is the color variability of the oil itself. So aside from the land features and the sediments and bathymetric features in the surrounding water, you can see that there's a dark oil, a dark brown, and then surrounding that region is a lighter area of oil. And this has some significance to the oil thickness. Next slide, please. Based on the Bond Agreement and Oil Appearance Code, the colors of the oil can be correlated to a range of thickness values, and this becomes very important in the containment and the recovery and the cleanup efforts. Next slide, please. It's a primary goal of NOAA to advance the quantification of oil thickness. It's one of the top priorities in the oil spill program, and it's not an objective that can be achieved without ground truth. So what we subjectively interpret from the satellite information, it must be verified with in situ observations. This is a critical connection and a fantastic segue into the talks that you are about to hear during this session. Next slide, please. So if interested, you can access the NOAA satellite oil reports at the URL below. It's publicly accessible. And this is a screen capture of our very simple homepage. Next slide, please. So the three main objectives that I would like to emphasize in this introductory talk is leveraging technology, using it to monitor and mitigate oil spills. Next, cooperating across public and private sector bounds and encouraging knowledge sharing. And finally, using scientific analysis for the betterment of oil spill response. So next we will hear from Flavio. Flavio, you have 6 minutes. The floor is yours. Thank you.
Okay, thank you. So good afternoon. I'm not sure if it's still good morning there, but here in Rio. So I'm Flavio. I'm a naval architect and marine engineer, as Alan said, and I'm the founder of Ocean Pact. We have several ocean-related services, and we are here to talk about interesting case of the grounding of the Stellar Banner, an ore carrier, and the response was caught by the pandemic in March this year. So I have a couple of slides, so I would like to share with you. Next one, please. So in February 25, an ore carrier grounded and full of cargo and with more than 4,000 cubic meters of bunkers, oil on board, and more than 300,000 tons of iron ore. This was a risk for our coast. And next one, please. Just to try to show where this is. This is in the northeast coast of Brazil, a place of very strong currents, and the ship grounded on a sandbank. Next one, please. So yes, this is where it is. The next one, please. Yes, so 60 nautical miles from the port, this ship grounded, and it was impossible to remove. There was a damage in the hull. So next one, please. And then we had to establish all the response actions that started, of course, with immediate equipment mobilization from the terminal that serves this ship. So Vale, one of the biggest mining companies in the world, the Brazilian Vale. And then the strategy was removing the oil first because they assessed that the ship was endangered and could break at any moment. Then they went for reinforcements, removal of the ore, and finally refloat the ship and sink in deep waters. Next one, please. So all the time we had the risk for an oil spill. We had to have the structure mounted for the response. So we have more than 40 responders in place, 1 oil spill recovery vessel, 2 current busters because of the strong currents, lots of containment booms, coastal protection, skimmers, beach cleaning equipment, and we were managing additional resources on 3 more OSRVs, oil spill recovery vessels, platform supply vessels that were mobilized from the oil industry to help the shipping industry, 4 port tugs, 1 helicopter, drones, and lots of equipment. Next one, please. So lots of stakeholders, of course, like in any big incident. So the ship owner, the agencies, including the Navy, the environmental agencies, the insurance, the transportation agencies, the ship agent, the local municipality, the company that owns the product, the ore, the one that sold it. So lots of entities involved. Next one, please. And this was the first time that authorities agreed in Brazil to establish a unified command. And this was very important to have the actions very well taken care without lots of disputes and fights. It was clear who was running the emergency and who was the authorities, and the decisions were made with our support. So we are also with O'Brien's in Brazil. So we have 50% of this joint venture, and we help the authorities, the customer. Our customer is Vale, the mining company that was selling the iron ore, and then we helped to organize all these response action and structure. But we were hit by the coronavirus in March very strongly in Brazil. Of course, I know you know the whole world, but here it started in March. And then we had to move all these command structure to work remotely. It was a real challenge, but of course the field guys should continue to work, but we should implement means to avoid the coronavirus to strike on board. So we established quarantine systems, rented hotels for crew change, testing. At the beginning, it wasn't easy to find all tests we needed. So it was an important challenge, this response, with lots of efforts for all stakeholders. And next one, please. So, and finally, the vessel was successfully refloated, we towed to deep waters as per all authorities, national and international approvals, and finally sank to the final destination after having all the oil removed and tanks cleaned, and all the maximum to the maximum extent possible to allow a safe operation. And that's what I was planning to show. Next slide, please. So just saying that this is what we do, and Ocean Pact mission statement always said that is to help society and our customers to know, use, and explore the coast, the oceans, and their wealth, ensuring their protection and preservation. And I think it was a good example, a successful one. Thank you very much.
Awesome. Hi, I'm Chris Chase. I'm with InterOcean Systems. We're a company that's been manufacturing, small manufacturer based in San Diego, making specialized oceanographic equipment and sensor systems and stuff that goes to the bottom of the ocean on ships. And one of our product lines developed about 15 years ago was an innovation in oil spill detection called Slick Sleuth. It's used in a lot of different applications, from offshore to inshore. And this picture kind of gives an overview of some sites where it would go: production plants and refineries, tank farms, piers, and offshore structures. Next slide, please. Like Flavio gave an example of a catastrophic event that was responded to, obviously with a lot of skill and success. And those are headline-grabbing events, but in fact, the majority of oil pollution to the marine environment statistically comes from shore-based sources. Those are industrial sources and urban runoff. So it's important to keep in mind that whereas, you know, there's this occasional well blowout or tanker grounding, the oil that enters the environment from other operations that are human sourced and shore based are a big contributor. And using technologies available today, much of this can be prevented or mitigated and minimized. And that's how our technology is used in the scheme of protecting waterways and oceans. Next slide, please. For example, here in San Diego, I don't have a pointer, but we're a good-sized city, but not an industrial port. Certainly a Navy town. But within this photo, there's multiple tank farms that are point sources that should be protected against. There's big vessels and bunker fuel and ship-to-ship transfer. There are co-located sensitive habitats with least tern nesting and green turtles and stuff that should be protected against the incursion of a spill, which is where our device can be used for early warning, ours and similar technologies. Obviously, there's all kinds of marinas and fuel piers, a marine terminal, the Port of San Diego. So a lot of opportunity for protection against point source spills. Next slide, please. What the primary drivers for people adopting technology, since there's regulations that are a primary driver. However, regulations are written in a way in the US and I think equally around the world that the onus is put on companies and facilities to self-regulate. So they should adhere to a set of best practices and standards, but there's nothing that says, you know, you have to do these specific requirements. You have to have 24/7 monitoring. You have to have 24/7 response capabilities should a spill occur. And so the motivation of, say, a refinery or a marine terminal or an offshore operation is to reduce their risk, and the financial driver is not having to clean up oil, which is expensive, not having to mitigate a spill, and not having damage to a corporate image. Not to mention, you know, the motivation that we should all have to protect the environment and our surroundings in and of itself. More and more there's adopted policies in companies of corporate social responsibility, and prevention fits into that mold. And again, the environmental compliance, which is Coast Guard and EPA in the US, and largely at facilities like power plants and refineries and terminals. That's the spill prevention, control, and countermeasure. If people are unfamiliar with that. Next slide, please. Our sensor technology is an optical sensor. It's like a camera system, broadcasts ultraviolet light, hydrocarbons fluoresce, whether it's a light sheen, silvery sheen, or slick. There's some signal return that the sensor can pick up and then make a remote alert for soonest possible response. It's a very scientifically sound and reliable method for remote detection of oil on the water or the ground. And over 15 years, we've distributed these sensors for all different types of applications around the world. Next slide, please. often I'm consulting at facilities and for applications as to where the risk lies and where the best positioning of sensor technology is. These sensors are highly sensitive, but they cover individual points. They're point sensors, so they're not like Ellen's satellites that sees these wide area swaths and tries to discern what's oil and what isn't. In this case, they're strategically located, and I've got a number of photos that show those examples. So when consulting, I use this heat map approach. It's an assessment tool to list out where is the oil or where are the processes. If an accident occurs, is there some likelihood, has it happened in the past? If and when it happens, where does the oil go? How does it escape the facility? What are the nearest, what would be the environmental impacts? Some areas are much more vulnerable than others. And using a Excel spreadsheet or some, a pad of paper, a whiteboard, you can sort of map out the risks and the relative probability of an accident and the impact of an accident, and then using that type of tool, figure out where the greatest benefit is to using technology to mitigate spill risk. Next slide, please. So at a tank farm and marine terminal, if that's applied, we know that upstream there's a lot of oil in the tanks. The tanks can leak or fail, and sensor technology at that point gives you early warning to where the oil's never going to come close to reaching the environment. However, a facility discharge, which is a fail-safe point, a sensor protects an entire facility that lies within. So a single point sensor can monitor as a fail-safe point for the entire inshore facility. Next slide, please. This is a tank farm down in Key West, Florida, which is a sensitive habitat where oil spills are feared and should really be avoided. And in this case, the sensors are installed at these floating roof tanks themselves, and also on the piers in the area. So if a leak or a spill begins, there's an instant alert, and facility personnel can respond right away and either prevent the spill from reaching the marine environment or really minimize the amount that does reach the marine environment. Next slide, please. I'm just going to sort of give some photo examples of where these type of sensors are deployed. This is not far from Flavio down in Brazil. They've actually got 9 spots on this pier now where they have sensors to monitor the pipelines that run along the pier as fuel transfers back and forth from the shoreside facility to tankers. Next slide. In the port of Nanaimo, they've installed a sensor which can be remotely monitored at the vessel control center, which is one location where if you have remote technology, there's 24/7 personnel monitoring ship traffic and other activities. So it's a logical place to have a mission control be aware of any oil spill monitoring points within a port and harbor environment. Next slide, please. An example in a marine terminal in Indonesia. You can see the pipes over the water with no type of secondary containment, and a rather rugged environment in that setting. Next slide, please. Near Huntington Beach, California, the Bolsa Chica wetlands, where they have production pumping wells, inside this wetlands. And if a spill occurs here, it also goes along the beach and some valued California coastline. So as a preventative tool, the sensors are installed around the wetlands and attached to tidal gate. So if oil is detected, a gate automatically closes and stops the flow of water between the sensitive habitat wetlands and the Pacific Ocean. Next slide. I'm just going to cycle quickly through a few more examples. Marine terminal pier, where loading arms attached to the tankers for loading and offloading product. 24/7 protection, including at nighttime and when personnel are not present. Next slide. In the Middle East, the primary market that's developed for this type of remote monitoring technology is for the intakes to the desalination plants, which are co-located with large power plants, since desalination requires a lot of power. They get almost all their fresh water from the desalination plants. These are mega industrial plants, and if they ingest oil from a spill in the environment or ships pumping their bilges, it's a really costly exercise to have to replace all of the filtration and process equipment. So the detection sensors here are to prevent the ingesting oil in the marine environment. Next slide. This is an offshore loading buoy, similar point source application. You can see a giant tanker connected to a buoy that has a pipeline that goes to shore. Next slide. This was a spill a couple of years ago that occurred in Refugio, which is just north of Santa Barbara. And it's an example of, had an oil spill sensor been installed at this culvert, which was just inland from the Pacific Ocean, you could have a gate there. The sensor would have detected oil, and it would have prevented what turned out to be a very unsightly and high-profile event here in California. Next slide, please. Throwing in a little humor, what we really need is an oily warning device. Next slide, please. And look forward to any additional dialogue that we have. Thanks for everyone's participation.
Thanks, Chris. Jim?
Okay, can you bring up the I can't see it right now. So hi everybody. My name is Jim Mullen of Earthwise Sorbents Technologies and also Arctic Foam. Next slide, please. I'm used to hitting slides, so bear with me, guys. We've heard from the professionals on this call about all of the problems and ways that we mitigate the problems. What we've done is we've gone in and figured out a different way to clean up the problems. And actually, Flavio has helped us in the past. It's a very large industry. Whether you're cleaning up products in a manufacturing plant, oil spills, chemical spills, or a fireman cleaning up accidents on the roadway, oil spills in the ocean. It's a very, very large industry. And we've come up with a product that is made up to 100% recycled plastics now that are sorbents, basically. And Flavio actually helped me in the very beginning. We have two products. One is polyurethane. We use our foam dust from our surfboard manufacturing to create pillows, all of our waste. And these pillows can be used, basically underneath any type of engine, any type of machinery. A little 12 by 12 pillow that we make will clean up 2 gallons of oil or chemicals. The other product, which is predominantly used around the world, is polypropylene. You see the big oil booms and the pads that you see in this picture right here. That's basically made out of virgin petroleum plastics around the world. We partnered with the largest sorbent manufacturer in the United States, and we've developed a way to create these pads and these booms out of repurposed plastic trash. And
Sure. Hello, everybody. This is Ellen again. We're having a few technical issues with Jim's connection. And while that's being sorted out, the technical team will be addressing some of the questions that have come in via chat. Do I have a minute to address the previous presentations, or did you want to proceed with questions to the... Excellent. I'll start the dialogue. I'll open the floor with Flavio first. Thank you for your presentation. I had a question for you about how your services are triggered. At what point during an incident are you alerted, and how do you begin to respond?
Thank you very much for your question. This can be very different. So in this specific case, we are already in charge of the oil spill protection for the Valley terminal, where this vessel used to work. So we are always there, but with a small team thinking more on some harbor spills, some minor hose rupture or something like this. This is the structure we have there, maybe with 10 or 8 people and equipment. When they had the incident, they immediately called us, and we mobilized resources from our main base in Rio de Janeiro and sent down equipment to the location. So, but this can be very different depending on the case. We have a standby contract, a retainer-based contract, or a small team already in place, or if it's a new customer, or oil from an unknown source, as we had last year in Brazil, where your kind of work was key to the success of the operations, that was seeing oil from the sky, and try to anticipate the touch zones or the areas to respond. But that's it.
Excellent. Thank you for that answer. And to Chris, early warning is key to any oil spill response. And as you stated, it would be preferable if it were to have been prevented at the source. But as we know, that's not always the case. You mentioned that inland spills make up a large fraction of what oil makes its way into the marine environment, but there is an extensive offshore energy industry. Even in the Gulf of Mexico alone, there's some 2,000 oil production facilities, either for drilling or production, and there's an extensive pipeline network. So my question is, your slick sleuth technology, is it employed on any offshore structures, or is it limited to inland oil tanks like you referenced in your presentation, or port areas?
He took away
there you are.
Yeah, there he is. Okay, we got him. We got you.
Can everybody hear me?
Whoa, we're back.
Hi, Jim.
That was a nightmare. My whole
So
computer.
we can. Excellent. No problem, Jim. We'll resume with your presentation. Chris, if you could hold the question. You received it? Okay. We'll resume with Jim, and we'll get back to your response. Thank you. Go ahead,
Chris,
Jim.
thanks for covering me. So can you go to the next slide? I'll try to be quicker. So in this world of sorbents, I mean, sorbents are made all over the world. They're shipped in from China. They make them out of just really cheap stuff. They use petroleum to make the product. That made no sense to me. I was like, why would we use good petroleum to clean up oil and chemicals? And so we went after trying to figure out how to make these polypropylene sorbents out of trash, and we did it. Now we've been testing with Findlay University in Ohio, one of the top tier oil recovery, chemical recovery, hazmat training centers in the world. And we've gotten most of the test results back, and our products that are made out of trash are as good, if not better, than all the leading competitors out there. It's a big deal. And we have a major issue with plastics on the earth. A major issue, as we all know. A dump truck is being dumped in the oceans every second of every day, all year long. And if you start thinking like 5 or 10 years, you go, oh my God, right? We have, I think, 17 trillion tons of plastic on in the world today. So what we've tried to do is figure out what part of that could we start helping with. And we finally figured it out. And we go to market the beginning of next year with all of our products. And Findlay University, Dr. Tim Murphy is one of the leading experts around the world. He was on the Horizon spill with Flavio, working that spill. And he's really helped us refine our products and be able to bring them to market. I'm excited to do that. Next slide, please. The idea of making a repurposed, recycled sorbent is a great idea, but in this marketplace, it has to be cost competitive, right? People are not going to buy the product if it's not. And that's what we've been working on the last year. We've installed new machinery, and we're ready to go. So next year, we can come to the market. Beginning of next year, we come out all over the United States, and then we're going to push globally. Next slide, please. This is a kind of a cool slide because it really showcases Flavio and I talked about this a long time ago. Flavio actually did it. Thank you. So if you think about it, we take plastic trash. We're talking 18-wheelers that come in, right? We sort it. We make our product out of it. It cleans up oil and chemicals on land and in the water, right? Then typically in the United States, it's taken to a hazmat facility where they burn it, incinerate it, generate electricity out of it, sell it back to the grid. They also repurpose the exhaust until there's basically no exhaust, no fumes, and then it goes through air scrubbers before it goes out into the air. So it's extremely clean energy production from an oiled product, right? Then there's what they call potash at the end, like an ash at the end. That ash can actually be utilized in cement and asphalt construction for roads. In countries that don't have that ability, like Portugal that we're working with right now, all they do is grind up our products and put that into the roads and into cement, and it helps alleviate potholes and soak up water that gets trapped in between the asphalt and cement. So it's pretty interesting. We have a full life cycle of our products that can, from trash to cleaning up oil and chemicals to creating energy or helping develop better roadways around the world. So I love that graph. And next slide. You can see some of our products here. The first picture is the surfboard pillows. The rest are pads, booms that are used behind giant ships like Flavio owns. We have all kinds of products for whether you're a giant petroleum company, whether you're cleaning up spills, whether you're the Coast Guard or the Navy or anybody, we have products that suit everybody's needs, and it's all made of plastic trash. Next slide. Perfect. I'm done. Thank you guys for
Thank
listening.
you. We have about 20 seconds until the session concludes. I apologize. It doesn't look like it's likely there's time for Q&A, but I want to
Hello and welcome to this session that we have here at BlueTech Week. This session is called Sustainable Marine Habitat Protection Using BlueTech Technology. We often have the opportunity to hear about the different marine mammals or ecosystems that are protected. If we're lucky, we hear about the people that are doing the actual work, but it's not that often we get the opportunity to hear about the instruments and the tools we actually do to carry out that work. I'm delighted to have an all-star panel with us here today. Dr. Leslie Field from the Arctic Ice Project, which is actually the most studied ice restoration effort in the world. Dr. Field will talk about how deploying these small field tests in key strategic areas are critical to helping us predict climate modeling. We'll hear from Rusty Morgan from PropSpeed. We'll hear about the different technologies being used in propellers to help prevent marine growth from bonding to metal surfaces below the waterline. We'll hear from Courtney Opsog from Blue Ocean Gear. Something that in preparation for this panel that startled me that I learned from this organization. So 640,000 metric tons of fishing gear are lost every single year in the ocean. And this obviously has huge global economic and environmental impacts on our ocean and ecosystem. So Courtney is going to discuss how their smart buoy technology actually tracks this fishing gear at all times. And finally, we'll hear from Dave Twining from Planck Aero Systems. And Dave is going to talk about drone flight technology and where this space is going and how this computer vision and artificial intelligence are enabling the next generation of drone autonomy. So without further ado, let us get to our first speaker, Dr. Leslie Fields. I'll turn it over to you.
Oh, sure. I can try. Is that better? Is that better for you? Okay, perfect. Thank you. Yeah, I have this ghost picture too. So thank you very much for having me here. This is quite an honor, and what an exciting program you've got. I just want to quickly acquaint you with an environmental nonprofit that I founded over a decade ago. It was originally called Ice 911 Research. Now it's Arctic Ice Project. And basically what we're trying to do is make time for the world to make the transition to decarbonized economy, basically, with less climate devastation by acting on one of the biggest levers on climate change there is, the loss of reflectivity of Arctic ice. And every degree matters. Every degree is worth fighting for, really is our watchword there. Next slide, please. We have lost a lot of reflectivity in the Arctic over the last just several decades, and so 30, 40 years back. And you can see that you can see my pointer, I hope. Bright reflective ice used to comprise a lot of the, at least winter time and through the summer, through a lot of the summer, Arctic ice up there shielding us, basically acting as our heat shield for a long, long time. And now, since this one is the best visualization I've seen, NASA, 1984 to 2019, we've lost almost all of that older reflective ice. Is it possible to run the video at this point that I had uploaded as well? Oh, perfect. So you can see the relentless decline, and it's really serious. As you look here, you're seeing what the inventory of sea ice that's over 4 years old is over time. You're seeing month and year as we're just clicking through the months. And you can see what the sea ice age looks like. So the older the sea ice, the brighter it is. And this is the key. As we've lost more and more ice, as we've melted more and more ice, there's less ice that persists through the entire year that allows us to then have an ice layer to rebuild the next season's ice on. So while we're still freezing every winter, you're looking at open ocean is pretty dark. It absorbs most of the sunlight. It's like wearing a black t-shirt, right? And the white is, the ice is reflecting much more. But what you're seeing is that every year we're losing more of this older ice And so every winter, more of the ice that's forming in the winter months is forming on open ocean or very thin ice. And so net, we're losing a lot of reflectivity. And we're only up to 2002. As you know, probably know, this is a positive feedback loop, meaning that the more that it happens, the faster it goes. It's accelerating. And that means that positive is not that we're having a good effect, but that it's just getting more and more relentless. So from starting about 2007, you will see this absolutely astonishingly quick decline of the remaining, largely reflective ice that we had. A lot of it flows out past Greenland, between Greenland and Svalbard. This is called the Fram Strait, and that's going to be an essential thing to notice. We've done field work up in Barrow, Alaska, Utqiagvik, Alaska here. This is important to note. And you can see almost all the reflective ice is gone. The predictions now are that by 2030, we are likely to have ice-free summers in the Arctic. And that puts us at risk of further climate change and climate devastation. So it's a serious thing. There we are. Can you please put me back to my slide set then, and the one that shows perhaps the one before this, that side-by-side comparison that we had up for a minute about losing this older ice means that we've lost albedo. We've turned a white t-shirt, a bright reflective heat shield in the Arctic, into a dark t-shirt, so we're absorbing more. Especially important in the summer when we have hot summer sun, right? 24 hours a day, right? And so that's a bad thing. The world's Arctic experts, polar experts, noticed this, right? And Don Perovich is one of the best known, is saying that back in March of 1985, old ice comprised about 30% of the Arctic sea ice cover, a significant amount, and now it's about 1%. So devastating losses. Next slide, please. And so by the same token that losing the ice is accelerating climate change, climate devastation, global warming, restoring it could be a very crucial lever on climate change to try to rebuild, to try to slow this global warming that we have. And so Peter Wadhams, another really wonderful ice albedo expert, is saying that the overall change in ice snow albedo in the Arctic could add as much as 50% to the direct global heating effect of CO2, meaning that all the forcing that we have from the CO2 in the atmosphere already, all of that's raising our temperature, we're adding another up to 50% to that, accelerating that loss even further, accelerating that global temperature rise, that loss of reflectivity, that loss of stability. It's 25% if you count sea ice only, it's 50% if you count the loss of ice and snow in the Arctic. Next slide, please. And so our mission is very simply put. We aim to restore the reflectivity of ice. And the question that I asked myself years ago was, is there some safe material that we could use to restore ice reflectivity? Because it was apparent, that this was going this direction, that it was a positive feedback loop and it would get far worse. We've screened many materials over the years. We may end up screening many more. But the material that's our current favorite is something called a hollow glass microsphere. And it's basically like, you can think of it as a very, very foot-friendly, yeah, thank you, much better, a foot-friendly kind of very reflective sand. What's exciting about this is we've chosen a material that won't have any affinity for oil-based pollution. It's not a plastic material, so it doesn't have any poison. In fact, it's basically silica, which is one of the most abundant materials on Earth, the silica-based class. And the magic is, if you will, that we go from open ocean, which reflects almost no sunlight, we just heard that, thin ice, which reflects some, multi-year ice, which reflects a lot, and with a very thin layer of this material, that's what these little white dots are meant to be, hair's width thicknesses, but large enough so you won't inhale them. What we find is that we can rebuild ice reflectivity quite a bit. And that's exciting. All the safety testing to date has been very encouraging. There's more that we want to do. Next slide, please. And so we have a mission and a timeline, which are saying basically that we've got 5 years really to finish out all the research and development questions to get this out there. And this first do no harm is really our first principle. We really want to maximize the positive the most positive impact with the least possible intervention. And we're trying to rebuild something that until recently was there. So we are nature-based in this way. If we're trying to use the most natural material, harmless material, we've got benign, we've got a lot of silica in all the world's environments already. And we are trying to do it in a way to rebuild something that until recently was there, to slow things down so that we have time to transition from the carbon-based economy and deal with CO2. We're doing this in a very rigorous, scientifically rigorous way. We've got peer-reviewed publication out there, and we've got another one that's on a targeted deployment that's getting submitted very soon. Next slide, please. And what it looks like on a pond, we've done tests always with permissions, laboratory tests certainly, but then out in the wild. On a pond, you can see that it increases the reflectivity right away of the ice that's there. This is a pond in Minnesota, segmented, and we can study how long does it preserve the ice for? How much more reflective is it? Next slide, please. I think we got another one, yeah. And we do a lot of climate modeling. By do a lot of climate modeling, what I really mean is that we commission experts to do this work for us, because we can't have all this range of expertise within our organization. So we contract with some really expert collaborators. And what we're finding is that indeed a leveraged deployment in the Fram Strait looks like it can be very impactful. And so we certainly don't want to change an entire ecosystem. We want to do a small bit of treatment to have a larger effect in the world. This looks like it's going to be quite impactful, and the paper's getting submitted imminently. And joyously, we don't need to carpet the Arctic to have an effect on basically allowing us to rebuild that heat shield in the Arctic. I think that was it for my slides. I'm around for many questions, and thank you so much. We are a nonprofit, and we work hard building these worldwide collaborations, even in COVID and Zoom-laden times. Thanks a lot.
Great. Thank you so much, Elizabeth, for a fantastic presentation. I'm excited for some follow-up questions that I know we already have for you. Rusty, I'm going to turn things over to you.
Okay, hey everybody. My name is Rusty Morgan, and it's really a pleasure to be here. I'm pretty humbled to be in the presence of so many people that have done really, really cool things for the world. But I'm a sales rep for a company called PropSpeed, and we manufacture a foul release coating. And we've been around for a while. We've been around for 21 years. We're manufactured out of New Zealand. And why we're unique is that we are, I'm sure you guys are aware of fouling out in the world or out in the underwater, but we're a non-biocidal foul release coating. So basically we figured out a way to apply silicone top coat to metals, plastics, fiberglass, aluminum, all sorts of things. It's pretty common in the recreational marine industry and some areas of the commercial marine industry, and boaters are using this product to basically keep their props clean and free of fouling for efficiency reasons and for maintenance reasons. But we've found a lot of really encouraging other uses for our product that I'd like to share with you. Can you go to the next slide, please? Next slide, please. Yeah, there we go. So like I said, what is PropSpeed? You've got a picture there of a guy putting it on a propeller. Basically, it's a easily paintable on coating that we put onto propellers, running gear, rudders, struts, shafts, that sort of thing. It's hydrophobic, which is the way that it works to keep fouling from being able to attach to a substrate. It's multi-season. It lasts for about 2 to 3 years, depending on your application. And anyway, like I said, there's a lot of systems in these larger ships that are using this as a benefit to keep fouling down. Can you go to the next slide, please? So I included this just for fun. There's a lot of people here that are a lot smarter than I am that would probably understand this, but effectively the way that a hydrophobic surface works is you're increasing the contact angle of the surface, so that basically, take a barnacle, for example, they are going to deposit a protein pad that's going to stick themselves to whatever substrate they're trying to stick to. Well, their protein pad can't form on the silicone surface. And as you get larger in angle, if you get more obtuse in that angle, it's harder and harder for the fouling to attach. Some low surface energy plastics like HDPE do this somewhat by themselves, but silicone is probably one of the best in terms of this, and that's what we're manufacturing. Can you go to the next slide, please? So the problem, obviously, is fouling. Now, I've included these pictures here because one of the things I wanted to talk about was that we've, in the course of our journey as a company, discovered that there's other uses for this product. And one of those is on the face of transducers, or a fish finder in the kind of common parlance. But we've had a lot of interest from people in the research community that are putting sensors out in the ocean, stationary sensors or buoy-mounted sensors that are sitting in the ocean for long periods of time. And they need a solution to make sure that the fouling stays off of them and that they can keep returning good data. We hadn't really considered this as something that would be commercially viable, but it turns out that there's a huge demand for this because traditional copper anti-foul paints aren't really effective, especially on a high sensitivity transducer. So we're able to apply that same silicone top coat straight to the face of the transducer. I've included two small pictures here just as an example, but it's pretty effective on a variety of surfaces. And we've got all sorts of different ways that we can get it to stick. And as I mentioned here, as sensor technology continues to advance and rely less on physical human access, such as on autonomous platforms, which there have been a lot of great examples from this conference here, the need for reliable and clean instrumentation, I think, is really critical to collecting that good data going forward. Next slide, please. So our solution was to create a product directly that was geared towards coating these sorts of sensors, and it's called Foul Free. And that image there is from a fish finder. Is basically when you have fouling on the face of your transducer, you can lose up to 50% of the resolution. So it's really critical that we keep these instruments clean. And like I said, returning good data is pretty important. Stationary sensors benefit from this because you've got reduced maintenance for a cleaning schedule. And for a lot of research organizations that are dealing on razor thin budgets, it's really important that we can reduce their costs as much as possible. So hopefully this product can help some people in that regard. Next slide, please. So why am I here? I intentionally kept my segment of the presentation pretty short because at the end of the day, I don't want to make this a sales pitch for our product, but I wanted to get across some of my thoughts and what I've seen in the industry, and hopefully get some really positive questions back from you guys because I really want to learn from you. So I'll read this off quickly, but I think that we're at an inflection point where the marine industry as a whole is getting away from biocides, and there aren't many effective solutions. In the lens of marine habitat protection, I think this is extremely important. We want to reduce the copper loading that we're finding in the sediments. We want to reduce the biocidal coatings because obviously they're killing marine life, and we don't want to see that. We believe we can make the marine world better, faster, and more efficient without harming the environment, and we thrive on finding solutions. So I'm here to learn from you. Now, I wanted to mention a couple of things because I think it's really interesting, some of the implications of why it's important to keep fouling off of marine vessels and instrumentation. And one of those is aquatic invasive species. And what we've discovered over the last couple of years is that there's more and more shipping companies that are looking towards hull fouling or propeller fouling as a vector for aquatic invasive species into a new environment. So I'd say in the last 20 years, there's a lot of emphasis placed on ballast water, and a lot of these ships are spending a lot of money on ballast water treatment programs. Well, now they're looking at the hull fouling as a vector for the aquatic invasive species, and companies like us, and there's a few others that are out there that are doing foul release coatings, we're finding that you can reduce the aquatic invasive species that are on a hull by having them slip off, and B, increase the efficiency of the vessel. So now a company really has a financial incentive to make sure that their props and their running gear and their hull are clean, not only for invasive species, but to save money also. And I think that's pretty important. So when we talk about this in the framework of the blue economy and economics, right, you've got the recreational marine industry, you've got the shipping industry, you've got aquaculture, you've got science. All of these industries are all coming together to, make our ocean a more manageable place. And I think that it's important that we have, as a community, solutions that are going to support the marine habitat protection going forward. Additionally, we've got new classes of vessels that are coming online. We've got the Tier 3 and Tier 4 engines in commercial shipping that are demanding more efficiency. You've got more and more hybrid and electric propulsion vessels that are coming online, even full electric ferries that we're seeing in some areas around the world. All of these things rely on the vessels being extremely efficient, and making sure that the fouling is kept to an absolute minimum is critical to that. And furthermore, like I said before, we really want to make sure we're getting away from those copper biocidal marine paints. So that I think that technologies like the type that we're developing, foul release silicone coatings, are going to be pretty ubiquitous in the market going forward. And, again, I'd love to hear more, some feedback from you guys to hear what you think. And that concludes my presentation for the day. I'll leave it up to everybody else. Thank you guys so much for having me.
Thank you, Rusty. That was fantastic. And I think, as I was researching, it was very clear about how your technology helps to prevent from fouling, but I didn't even think about something as economical as increasing the efficiency, which may even reduce not only fuel costs for vessels, but then the amount that they're polluting in the ocean in the first place. So I'm excited to dive into that. So we're going to move over to Courtney, who is going to talk to us about blue ocean gear. Courtney, the floor is yours.
Thanks, Jason. No, thanks for having me here today. I'm really excited to talk to everyone, and also it's been great to hear about what everyone else is working on. Can we go on to the next slide, please? Thanks. So lost fishing gear is one of the largest environmental issues facing our oceans today. It's one that I think not a lot of folks really think about, but again, it's 640,000 metric tons of traps and nets and lines that are lost every year into our oceans, and this gear continues to fish without ever being harvested. And so this phenomenon known as ghost fishing can actually significantly reduce fishery stocks. About 30% of the world's fish are actually end up getting consumed by ghost gear. And plus it contributes to the plastics in the ocean. And it's a very expensive problem as well. So fishermen are spending billions of dollars every year on fuel, just going to try and searching for their gear, as well as replacing lost gear at the end of every season. And in addition, there's a lot of harvest potential lost because of this unlimited competition that's coming from ghost fishing. And so there have been a lot of efforts for cleanup efforts and recovery programs to retrieve lost gear from the ocean, but to really tackle this problem successfully, I think we really need to prevent it from happening in the first place. So they've shown that actually a 10% reduction in ghost gear can increase biomass in fisheries by about 40%. So can we go on to the next slide, please? Thanks. So we've spent a significant amount of time out on the water with commercial fishing fleets, just observing their operations, listening to the problems that they're having, and figuring out how to tackle them. And what we found was that this issue fundamentally stems from a lack of data from out on the water. And we realized that potentially the fishing gear could be used to provide that information. Right now, when fishermen set their gear, they typically just put a mark on their GPS plotter in the wheelhouse of their boat where they've set it. But because the ocean's such a volatile place, their gear is rarely there when they go back to get it. It's always moved, sometimes very large distances. And so we realized that if we could track gear out on the ocean, because a lot of these problems could be resolved. Let's go on to the next slide, please. So we developed our smart buoy systems. These are just basically GPS tracking buoys that let fishermen track their gear at all times, and then they get an alert if something's gone wrong, like it's moved too far. They just attach on to their standard gear in a very simple manner as a trailer buoy. And the data is sent either via satellite directly to the cloud or via a mesh network, so that the fishermen can use a mobile application on their smart device to tell where all their gear is. And let's go to the next slide. We have additional sensors on the buoys as well, and this actually helps give a bigger picture of what's going on out on the water. We've seen data coming in from buoys on trawlers that have accidentally dragged gear, or gear that's gone underwater and come back up due to being dragged under by currents and strong tides. All of this is information that help the fishermen with timing their trips better, being more operationally efficient. And then as we get more buoys and more sensors out on the water, we can actually use fishing gear to provide very critical ocean condition data for both fisheries as well as fisheries management. Let's go on to the next slide. So at this point, we're actually running small trials in various fisheries throughout North America, and we are getting ready to deploy in larger volumes in 2021. So it's kind of an exciting phase for us. And then let's go on to our last slide. We'll keep this relatively short. I think it's a really interesting time in the fishing industry. We're seeing a lot more dependence on technology and on data. And I think the way that we've addressed this issue, we're trying to use that technology and really, create kind of a bridge between both conservation and industry so that we can actually have a solution that can improve ocean health and reduce ghost fishing, but at the same time, give fishermen more of an economic advantage in their operations as well. And happy to take any questions as well as we go forward. Thanks very much.
Thank you so much, Courtney. Obviously, ghost fishing, ghost gear has been a huge issue and a literal drain on the economic resources of our maritime community. And I just applaud you that the first way you started off that was you went and you listened to what the issues were from the local fishermen and did your research, because it's not an easy problem to solve. And so I commend you for that. Okay, without further ado, our last presenter, but certainly not least, I'm going to turn things over to Dave Twining from Planck Aero Systems, who's going to talk about some really exciting drone flight technology. Dave, the floor is yours.
Great, thank you very much. So Planck Aero Systems, we build embedded systems for unmanned aircraft. A lot of times that's on the control side, but we also do build systems for in the computer vision space, especially around things like object detection and tracking. So that's really what I'm going to be talking about today, is an application of that for a project that we've worked on with several different partners to use unmanned aircraft to help preserve and really save the North Atlantic right whale population, particularly in the Gulf of St. Lawrence. So next slide, please. North Atlantic right whales are a critically endangered species. There's less than 400 individuals left in the world, and there's really two main factors that are affecting that population. The first is actually relevant to Courtney's talk. It's gear. It's gear entanglement. One of the locations that she marked on her trial slide is the crab fisheries in the off the coast of Canada. That's the same area that we're talking about here. The other major factor that is killing North Atlantic right whales is that they get struck by ships. So it's a very, very active shipping lane through there, one of the busiest in the world. North Atlantic right whales have been getting pushed further and further north and right into those shipping lanes. And year after year, they're getting struck by ships. So the goal is really to figure out where the North Atlantic right whales are, and if they are in shipping lanes, how to avoid hitting them. The basic, very, very obvious way is to alert the ships and tell the ships just to slow down. Right, it gives them time to maneuver, gives time for the whales to get out of the way, and if there are strikes, the hope is that they would be less lethal. Next slide, please. The current way that this is done is using a manned aircraft. So that is a Dash 8 flying from a regular airport and surveying the area manually, really, right? It's trained marine mammal observers looking out the window and trying to spot whales. Meanwhile, you have all the cost associated with operating this manned aircraft. Now, this approach is actually quite effective. Marine mammal observers are really good at their job, and they can spot these whales from manned aircraft very well. However, it is very costly. Obviously, it's risky putting people up in the air day in and day out. It's extremely expensive in terms of being logistically difficult as well. Like, it just takes a lot of effort to make this happen, a lot of moving parts, and really it's probably not very sustainable. So next slide, please. So the goal here is to use unmanned aircraft with onboard artificial intelligence to automatically detect the whales and alert ships of their presence. So we worked with Transport Canada and the University of Alaska at Fairbanks to operate this aircraft that you see here from the Gaspé Airport over the past several summers. Plank's role is actually all on the image processing and artificial intelligence side to actually go detect the whales. The challenge there is these aircraft are flying potentially 100 miles or more offshore. They're capturing thousands of really high resolution images per flight. It's very difficult to spot the whales, but for this to be effective, this whole system has to be very responsive. So it's not practical to survey the area, come back land, spend a couple hours downloading the data, spend many hours processing the data, and then say, okay, we have some whales here, but that data is then 12 or 24 hours old, and it's not really applicable to ships that are transiting through this. Next slide, please. So here's an example of a normal picture taken from this aircraft. It goes to show you how difficult it might be to spot whales. These are actually pretty good conditions. There's not a lot of waves. This picture is taken from about 2,000 feet from a camera mounted on the belly of that aircraft that you saw a moment ago. But it's even difficult to have scale. So using people in the loop to do the detection here is very difficult, but I promise you there is a whale in this picture. So next slide, please. So this is what the computer vision system sees. It is able to automatically detect that whale, which is in the green box in the middle of the inset box there. We also are able to geolocate it really quickly, essentially in real time. So as soon as a picture is taken, it takes a second or two to process on board, and then we know where it is. And that position can be transmitted over a sat link without having to transmit the whole image. Get it to the operators, and they can make an assessment from there. So still, I just like this visual because it shows you how difficult this can be to do. So next slide, please. That's where the whale is. So from this big picture view, and you really need a big picture view so that these unmanned aircraft can cover a lot of ground, a lot of area for each flight. But being able to automatically detect these whales in the imagery in something close to real time is really essential. So next slide, please. That system we call OpTrack. Some of the key benefits is that it's very accurate, real-time detection. It's cost-effective. It's persistent, right? It doesn't get tired. Eyes don't get, don't need coffee. It's efficient. It keeps people out of the air. It keeps them in, safe environments where they can really do their job. And it's also upgradable and adaptable. So this is all about North Atlantic right whales, but that same system can be adapted to apply to lots of other scenarios where you may be looking for other objects. So that may be ships or other animals in the sea, or even animals over land. Next slide, please. Oh, I guess that's it. Yeah, so I'll wrap up here. I'm happy to address questions, and thank you everybody for your time. It's a great panel as well. So very pleased to be a part of it.
Great. Thank you so much, Dave. And I'm going to jump right into questions. I know we don't have a ton of time. One thing I would note to all of our listeners, I hope is clear, is that these technological innovations that are happening are not just a business venture, but are critical to marine conservation at large. And so I thank all of our panelists for really going into how that is being applied. I'm going to start with Dr. Field, and I'll just ask our panelists to, I know you have amazing things to say, but in the interest of time, to keep it as brief and concise as possible. But Dr. Field, first you really scared me because, this idea of this impact on reflectivity, that we're on pace to have ice-free summers in the Arctic by 2030, which is just 10 years away, is terrifying. But you also gave me some hope with the solution and the material that your organization is working on. My question is, how has the rest of the world perceived your solution? Is it being applied? Is it being applied at the rate it needs to be? What do we need to do to take your solution and meet the scale of the problem?
Okay, yeah, that's something that could take a very long answer, but I'll try to be really quick.
I know, forgive me.
Yeah. It's an uphill battle because if you are concerned about climate, you tend to want to not do much in the way of, interventions. It is very often the philosophy. And, what this project comes from is realizing that without interventions, we won't have left any of the ecosystems that we're hoping to guard. And so that can be a hard sell. We are doing something called climate restoration, Arctic ice restoration, and that's a fairly new concept. It's only been entering the vocabulary the last couple of years. So it's not only, it's like, does mankind really know how to intervene, and then should we, and could we actually restore something? And the answer is, it looks like this may very well be needed. But what you need with this is, I believe, some external governance and policy and funding and such to make sure that these kinds of interventions are ranked against each other for, are they safe, are they effective, affordable, all of that. And that takes time. So it's been an uphill battle. We have had permissions to test, in numerous places, not on ocean yet, but on, fresh water. And we're doing a lot of laboratory tests. And what we're finding now, just this last year, it's been really exciting, despite COVID, the ability to form international collaborations, national and international collaborations with much larger organizations who can fill out the expertise that we don't have is really exciting, and gives me hope that we could get there in time. And so that's a beautiful new phenomenon. And it's terrifying, it's urgent, but there is hope. And in fact, in my business, I kind of collect many of these climate restoration solutions. So there's probably more out there than you think. And that too is a cause for great hope.
Great. Well, that's good to know that there is hope. And I'll remind everyone the Arctic Ice Project is a nonprofit. And so, definitely looking for support as always. So check them out. Okay, Courtney, I'm gonna go to you because this was really fascinating. And this is sort of revolutionary. I mean, this idea, even as Dave mentioned, whale entanglement, we're losing incredible amounts of economic resources. We're just needlessly killing marine mammals that we're not even using because, for food or other commercial activities, because they're just lost at sea, literally. My question is sort of the same one that I posed to Leslie. Who has embraced this solution? What do we need to embrace this smart buoy technology? I assume fishermen have a large incentive to use it. Are they using it, and how can we scale it to commercial activities?
That's a good question. I think we've been, and I think the interest is coming from a variety of different groups for different reasons. The from the fishing fleets. A lot of it is around how can they improve their operations too, and that's where a lot of them do spend hours out on the water just trying to find their gear, even if they don't lose it. It's hours just trying to find a single string of traps, and that's time on the water that they don't need to be they're not actively fishing. So I think that's where, part of it came from. Part of it is also from regulatory agencies that are getting more interested in ghost gear and preventing ghost gear. The United States, Canada, and Mexico are all now members of the Global Ghost Gear Initiative, meaning that they are starting to put more efforts towards preventing gear loss and finding ways for fishermen to address that. And so we're definitely engaging with that. And then we have been approached by both fisheries and management agencies regarding the whale entanglement aspects that Dave was mentioning. I mean, these are critical and urgent issues on both coasts of the U.S. And so our buoys can help in several different ways, just given the suite of sensors that we have on can a detection be entangled, as well as just preventing lost gear. You're removing lines from the water that could otherwise be a potential entanglement risk.
Thank you. So Dave, let me go to you then. So how do you see the technology that Courtney was talking about interfacing with the technology that you discussed? Do you see these as potentially complementary technologies, or do you see that maybe you would use one in a specific situation and the other in a different situation? I mean, what are your views on how these different applications interface or not?
Yeah, I think there's certainly an opportunity for things to interface and complement each other. There's a lot of challenges involved, and it's still very early days, especially on the unmanned system side. You know, I talked about unmanned aircraft, but there's also surface vehicles, subsurface vehicles, all kind of doing their part in this this North Atlantic right whale preservation project. But being able to pull all that information together and have a better operational picture is something that I think there's a lot of interest in, and having, knowing where the fishing gear is and having that be part of that operational picture, and fusing that with the rest of the data that's available is really important. The fact that Courtney's systems can alert you in something close to real time, right? Either through a mesh or through a satellite link, is incredibly important, because it allows you to, if you know a whale's at a certain spot because an unmanned system potentially saw it, and you know where the ships are from AIS systems or something else, and you know where the shipping or the fishing gear is, actually is, right? Not where the fishermen think it is. Then having that big picture allows the decision makers and the regulators to, find solutions that are workable, especially when you're dealing with a lot of different interested parties, right? Those shipping companies don't want to slow down. They're going at an optimized speed. The fishermen want to fish, right? They have a livelihood to make. So the more that regulators kind of put their fingers into things and make it difficult on those parties, the harder it is for them to accept the solutions. Whereas the more information you have, the easier it is for everybody to get on board, because it's probably a less impact on what they need to do on their, for their regular jobs.
Great, thank you. Rusty, I'm going to ask you a question. Oh, go ahead. Do you want to reflect on that, please?
Well, I was just going to chime in that I think that there's one common thread here that I think is really critical, in that, obviously anybody who has an environmental bent to them wants to see the world become a better place. We want to be greener. We want to be more efficient. We want to do all these things. And as you pointed out, Dave, regulation is hard for industries, right? These people are in the business of making money. And, if they can do it better, they probably will, but it's got to be cheap for them. So, the sole reason why my product even exists is because we want to solve the problem of cavitation on propellers, make boats more efficient. Great. Can we save the world while we're doing that? Hooray. If we can make money and be a successful company at the same time, that's good. And just like I mentioned with aquatic invasive species as a factor of hull fouling versus ballast water, well, ballast water treatment costs a lot of money and it doesn't give anything back to the company. But when you talk about hull efficiency, all of a sudden now you're reducing the aquatic invasive species, but you're really helping those companies become more efficient and save a lot of money. I mean, we're talking about $1 million per vessel per year on fuel efficiency alone. So if we can kind of combine all of those things, right? If Courtney, we can keep, it's fishing gear is extremely expensive. All those ropes, all those nets, everything costs a lot of money. It affects their bottom line. Well, let's save them money and save those whales at the same time. And I think that for me, I mean, that's why all of us are in this room right now talking. And the economic side is going to be what solves the problem, not the idealistic side, I believe.
So let me ask this question, and this is posed to all of the panelists. So whether it's the IPCC report released a few years ago that gave the 12-year marker, or the high-level panel for sustainable ocean economy, but all of the kind of scientific markers that say this is where we got to get to by this date, and the international community has agreed on that, has the economic incentives in these innovations, are they on pace to meet where we need to be at the time we need to be there? In other words, are there companies like yours innovating fast enough with the right kind of regulatory framework that they can scale to actually meet where we need to go at the time we need to go there? So I'll open that up to any of the panelists. Leslie, it looks like you want to answer that first.
I have some opinions for sure. So we look at in the U.S. alone, over $1 trillion of damage due to climate-related damage from 1980 to recently. That's a NOAA report recently. So that's a horrific amount of money. But I don't see that kind of money being devoted to climate solutions. And so, frankly, I'm worried, right? Very little of the worldwide philanthropy goes towards climate in the first place. And so it's, and there's more investment going in and, you know, some of the carbon recovery and things like that that are needed, but it's still awfully small compared to what the needs are by when we need it. So frankly, I'm worried. We need some better mechanisms, and I see them beginning to grow. I see them beginning to bubble up, but yeah, it's a terrific question.
Yeah, the environment was one of the last given categories in American philanthropy last year, and within that category, which is already low on the totem pole, less than 5% of environmental funding went to the ocean. So yes, it's quite underfunded and under-resourced. Anyone else want to take a stab at that?
I think that we're on kind of the cusp of a lot of this technology changing. I mean, you look at something like, remember back in 2007 when gasoline was $5 a gallon? Well, suddenly there's an explosion in electric cars, right? So as soon as you kind of have that inflection point of these two things becoming all inclusive, as in, you know, the technology is there and it's going to be cheaper for everybody, then the technologies start getting adopted. And I think from a technical standpoint, as a scientific community, we're getting close to there, to having these technologies be available and ready to be employed on a large scale. But I don't think we've quite jumped over the cliff yet. And I think that, you know, over the next 10 years, we're going to see it rapidly accelerate.
So I want to give all of our panelists a time to say any kind of closing thoughts, and so use this to say anything you want. One kind of question I am curious about is if the financial incentives from the government agencies are aligned to sort of meet that demand. In other words, are they fulfilling where we need to go, and are they matching where the private industry is going? I know that's a little bit of a loaded question, but I think one thing we do need to examine is how the private and public sector can work together jointly to meet the scale of this problem. But let's just go around. I want to give all of our speakers time to give closing thoughts. Courtney, I'm going to start off with you.
Sure, thanks. I think, you know, Rusty hit on this a little bit too. I think, you know, we're all tackling problems that both have an environmental aspect, but also there's other aspects to to these businesses that will benefit the customers, the users. And I think they don't have to be mutually exclusive anymore. I think that there are actually, I'm seeing a lot of companies, a lot of tech startups working on similar things where there's both together, something that has a conservation or an environmental aspect, but also has a very, there's a reason beyond that for folks to buy it, that it actually is going to save their money or improve their business. And I think that's where we're probably going to see a lot of the first developments go. I think that we've been very fortunate in having support from both from NOAA and National Fish and Wildlife Foundation, as well as private investors. But I think there was some NOAA lightning talks yesterday about how different opportunities for ocean tech startups and working with government funding. And I think that we're moving in the right direction. I think I agree. We'll see a lot of changes. I think in the next 5 to 10 years, things are going to definitely be changing in ocean tech. There's a lot of exciting things being done. So it makes me feel better to know that there's all these smart people out there working on some of these problems that can help. So
me too. It makes me feel better too. Well said. Dave, some final thoughts?
Yeah, sure. I just think that even though it is still relatively early, I think the smart companies out there, large and small, are the ones who are already embracing the need for doing things better from an environmental impact perspective, because they see the writing on the wall. This isn't going to go away. They can't just put their head in the sand. Other organizations maybe aren't doing that, and I think they'll be playing catch up later from the from the economic side of things. So it's really encouraging to see that some very large companies, as well as government agencies, are leading the charge in some of these initiatives.
That's great. Leslie, some final thoughts for us?
Yeah, I agree that I think we're having a change in our country too, right? Heading towards the right direction on addressing climate. Your talk on the whales, I got to hear a talk some months ago on just the natural capital value of whales and how insane it is to kill them just for a little bit of meat, sell it right then, or accidentally run over them with a tanker, right? When you consider how much food they actually cause by just living and doing their life. And I think that natural capital aspect of things really has to start getting valued in, so that things like we could regard as a common good, like Arctic reflectivity or like the Amazon, right, are valued properly so that they can, show up in the economic considerations as well. I will say that as a philanthropy, if you're interested in us, I will say our website is arcticiceproject.org, and you can follow us and all of that. But, basically, philanthropy has been filling in where governmental and corporate funding haven't quite gotten there in some of these interventional solutions yet, but they're coming. And I think all of it working together is really important. And I appreciate being able to talk here today about this. Thank you.
Thank you so much, Dr. Fields. Rusty, take us home.
Yeah, I think that Dr. Fields, along with that, I think that there's a really unique joining between the philanthropic or scientific community and the commercial side. And sometimes there will be researchers that will come up with this amazing idea and it won't get the funding or it won't get the attention that it wants to. But then you get a company, say like a global shipping company, that says, oh, geez, that might save us $10 million this year. And they're going to invest a lot of money into figuring that technology out and making it work. And, that's why you see hydrocarbon companies investing in wind and solar energy and that sort of thing. It's because economically it makes sense for them. So while you can scream as loud as you want from the rooftops, at the end of the day, it needs to make economic sense for them. But I think, as everybody here has said, those two things are starting to come together. And it's really important that we just, share and collaborate as much as we can so that all these ideas can really come to fruition and bubble up to the surface.
I agree. Collaboration is so important. Yeah.
Absolutely. Yeah. And Rusty, you said it best earlier when you said you were here to learn. I certainly learned quite a bit. So with that, I want to thank all of our participants. I want to thank Dr. Leslie Fields from the Arctic Ice Project. I want to thank Rusty Morgan from PropSpeed, Courtney Opsog from Blue Ocean Gear, and Dave Twining from Planck Aerosystems. Thank you all for sharing your great work. And with that, we'll conclude this session. Thank you.
Thank you so much. Take care.
Thank you.